Great, thank you guys. Just give me one moment. Renaming myself. Okay. And let's get started, guys. See where we are. Okay. From an API. Okay, guys. So let's say we'll have a quick and a friendly review, and we'll also need one of you guys to get onto your Azure Lab account and test and see if you're able to get into the if you're able to create the database today, guys. So any one of you, anybody logged into the lab? Let me know. Or if one of you can log into the lab and let me know. While you log into the lab, let me make a little bit progress here and see what we have, guys. Okay. So I think yesterday we briefly discussed about Azure database, Azure SQL database, and also Azure SQL, Azure managed instance. Okay. By any chance, do any of you remember what is the difference between Azure SQL database and Azure managed instance? There is a subtle difference between Azure SQL database and Azure managed instance. Okay, Azure SQL database is nothing but the SQL Server database on the cloud, whereas managed instance is the ones which comes with the latest and the greatest features. For example, the cross database import is one of them. And a few features that Azure SQL database does not provide are additionally provided. It is generally used when we are trying to migrate from on-premises to the cloud SQL server database. That is one of the main use cases of that, guys. Okay, we'll go over that one more time again today, but let's come back here. See, back to here. Okay. So there's a quick description. Yesterday we briefly discussed. Let me do a little bit of cleanup. SQL Server on virtual machine, that is where we are manually installing SQL Server database. Azure SQL database is the platform as service, and that is automatically installed by the Azure guys. And coming to managed instance, it is same as SQL database, but on top of it, it is also used for cross database queries, mail support, SQL Server agent. It is mainly recommended when we are migrating from on-premises to SQL Server database. Okay, so again, we'll talk about these things in detail. Let's say I come back here. Here is Azure database for MySQL. In other words, we can use MySQL database on Azure. It is also fully managed by now. Hopefully you guys are comfortable and you understand what is fully managed, guys. Okay, scalable, again, auto scalable, that is built into the cloud. So if the number of requests, number of the load balancing and the scaling will automatically, scale sets will automatically take care of it, guys. Okay, let's see, back to its supports. Okay, these are the editions it supports. Community editions are free generally. 4.9 availability, there are 4 nines. I think that's approximately 22 minutes or maybe 26 minutes downtime per month. And otherwise, and that's a pretty good one, guys. Okay, choose single zone or zone redundant high availability. So we can have the database installed in a single zone, or we can also have it installed in multiple zones. We'll talk about the different kinds of zones in a bit. Automatic updates and backups. So again, they're automatically provided by the Azure folks. They will take care of the automatic updates and backups. So as a result of that, we do not have to manually maintain another database team who's only taking care of the updates and backups. These are nothing but the database administrators. They're very, very highly skilled and very, very highly paid. So again, the business saves a lot of money by that one, guys. Okay. Alternative Azure database for MariaDB. So in other words, if you go into the background of MySQL, MySQL was acquired by Oracle. So now MySQL is not open source, but it is Oracle's database. So a few team members of the MySQL came out and they renamed it as MariaDB. MySQL is more precisely MariaDB, and that is also provided by the Azure. It is community developed. It is same, nothing but the MySQL, commercially supported for fork of MySQL. So if you need commercial support also, the support is provided for the MariaDB, guys. Okay, everybody okay with this slide, guys? Quick yes, please. Back here. Now here comes the PostgreSQL. This is the one we tried, various SQL options and things like that earlier. So again, this is also provided by the Azure cloud. It is fully managed. They take care of everything. It is intelligent and scalable. More precisely, behind the scenes, PostgreSQL can sit on a group of servers like Hadoop. It will automatically scale itself. So it is in other words, behind the scenes, it is more sophisticated than MySQL, guys. Okay. Again, 4 nines availability. We can choose the zones or the zone redundant availability. Remember, zone is a group of data centers, and a group of zones is nothing but a region. A group of regions is nothing but a geography. Okay, automatic updates and backups, just like MySQL, SQL database, they're also provided by the Azure Postgres. Single server and hyperscale options. So hyperscale means scale to hundreds and thousands of nodes and execute queries across multiple nodes. That is like the Hadoop architecture, the architecture of the master and the server. It is automatically provided in PostgreSQL. That is why I have said it is more sophisticated than MySQL, guys. MySQL comes with a single database, whereas PostgreSQL comes up with master server architecture behind the scenes. We don't need to go into the details of the master server architecture of the Postgres, but it is similar to the Hadoop that we have discussed in the previous weeks, guys. Okay, as simple as that. So that is what is referred as hyperscale. You can go to even hundreds and thousands of nodes also, and that is where the traditional databases fail. That's what is the good thing and the great thing of PostgreSQL, guys. Okay, everybody okay with this slide, guys? Quick yes, please. Okay, Amulya, everybody okay? Okay, good. Let's move to the next one. Okay, so imagine here is a scenario, guys. We are migrating a Microsoft SQL Server database to the cloud. We want full access to OS and Microsoft SQL Server in a server installation. So what kind of a scenario is this, guys? Let me give you a hint here. Read the question. Let me see. I want one of you to come online. Let's say, okay, Niharika, can you unmute yourself, please?
Yes, sir.
Okay, go ahead and read the question.
You are migrating a Microsoft SQL Server database to cloud. You want full access to OS and Microsoft SQL Server installation.
Okay, so I'll give you a few options here. Would you use, they're saying they want to use Microsoft SQL Server, which means we can use a Azure SQL database or Azure managed instance or Azure on a VM. That's a tough question. What do you think we should do?
You want full access to OS and Microsoft SQL Server installation.
The catch here is they want full access to operating system and Microsoft SQL Server installation. They want to install it.
They want to install it infrastructure.
Good.
First, very good.
That's a scenario where we go for IaaS. So SQL Server on VM. We would install SQL Server on VM. So we're just taking the infrastructure. We're just taking the VM. VM is infrastructure, and we are installing the SQL or the operating system and the operating system on that. Okay, read the next one, Niharika.
Okay, you are migrating a Microsoft SQL Server database to cloud. You don't need full access to OS. and Microsoft SQL Server installation also. However, you need access to database mail and SQL Server agent. Okay. Okay. However, you need to access mail and SQL Server agent. Yes, infrastructure second. Software as a service like that.
Okay,
Because mail and server.
I'll give you a hint, or I'll give you a few choices. Do you think you will go for Azure SQL database or Azure SQL managed instance?
Managed instance.
And why?
Managed because we don't need access of OS and server. So database no need.
More precisely, Azure SQL database will not give you the features of database mail and SQL server agents. It is only managed instance which is giving you that. That is why we should go with managed instance. Okay, Niharika?
Yes, sir.
Okay, continue.
You want you want create a new managed Microsoft SQL Server database in cloud.
You want to create a new SQL Server database in the cloud. Okay, so what would you do?
Azure SQL database we need.
Okay, that's a slightly confusing question. But let me see if I can give you a hint here. Let's say you can use Azure SQL database or Azure SQL managed instance.
Database, sir, we can.
You want to create a new managed SQL server database in the cloud.
Okay, means managed instance we have to.
Okay. In other words, more precisely, they're saying you want to create a new server, managed SQL server database. So we can go with Azure SQL database and Azure SQL managed instance, either of them.
Okay.
Even at the time of creating Azure SQL database, we create a new server. That is why we will be, we can say it's Azure SQL database, okay? Are you logged into your cloud lab, Niharika?
Just logging in, sir.
Okay, no problem. Let's continue. Okay, let's see. Which category of, okay, read the question, please.
Which category of SQL is this? Grant select on to user. Control. I'll
give you a
control,
hint.
Sir.
Is this data definition language, data manipulation language, data query language, or you know, there are a couple of things.
DCL control, sir. This one comes.
Very good. Okay, that's a data control language. Data control language is where we're giving the permissions. Permissions is nothing but allowing the control, giving the users the access to, again, giving certain users to query, certain users to insert, update, and delete, and so on. Okay, so let's say which. Go ahead, read this.
Which category of SQL is this to create table course? Definition, sir. Data definition language.
It's a data definition language. Okay. How about this one?
Your queries on relational databases are slow. What first thing you would consider doing? Your queries on relational database are slow. Okay, slow. Data in the data query language, we go and check those.
Good answer. So that's a tough question. It's actually we look for indexes. But do you remember why? What is the advantage of indexes, Niharika? It's a slightly tough question.
If we know the index of, if you know the data and the index of that, we can directly access it by indexes. It's simply easy.
Very good. So what is the advantage of having an index? We're accessing it by index. What is happening behind the scenes? If you recall, By default, indexes are nothing but binary search, binary trees, and things like that. So as a result of that, the search is much faster. That's a slightly computer science related thing, but something to no scan, no table scan, but it is more of a thing is what is an SQL way of saying it. But again, remember that is what is an index. Index it makes it faster. So if our database or tables or queries are slow, it means the first thing that we could check and see if there are indexes or not. Okay, Niharika? Proceed, please.
Your colleague asked you to normalize your tables. What should be your goals?
Tough question. Why do we normalize the data?
Normalize to understand for everyone.
Okay, more precisely, high data integrity. What is the meaning of data integrity, Niharika?
We can access at one place.
Genuine data, trustful data. Don't store data which is not genuine, which is not trustful. As simple as that. Okay.
Okay.
What is minimum data redundancy or duplication mean?
Data we can if you miss the data or the data is deleted or any chance, we can access it by duplication, like replication.
Okay, so in other words, remember the example of the persons and the cars. Imagine Pravalika has a car, and let's say it's a Tesla car. So we have two tables, person and cars, and what we are doing is we are saving a Pravalika in persons table once. You don't need to save it more than once. It is not required. That is what is data duplication. Similarly, her Tesla car can be saved once in the cars table, and you don't need to save it multiple times. The same thing, that is data duplication. Catching it, Niharika?
Yes.
Read,
Yes.
please.
How can you offload read-only workloads from Azure SQL database?
That's also tough one.
How can you offload?
Offload means how do you separate?
From managed instance.
Okay, good answer. But more precisely, read-only replicas. So we maintain another database, an exact copy, which is nothing but a replicated copy of the database. And whenever we need to do a read, we will go to this particular database and read the data. When we need to do insert, updates, and deletes, we will do on the original data or on another replica. That is called read-only replicas. Okay.
Okay.
Good.
Okay, sir.
Yep. Thank you, Niharika. So let's talk a little bit about Azure Cosmos DB, guys. And let's see. Stop the share here for one moment. Okay. Sharing the screen again. Here we go. Okay, relational data we discussed in detail yesterday. It's nothing but the structured data. And let's say I come back here. This here. Okay, we spent some good amount of time, if you recall, guys. That is nothing but the structured data. And SQL database, Azure SQL managed instance, and SQL server on virtual machine. Then you have PostgreSQL, you have MySQL. The open source version of MySQL is renamed as MariaDB. We looked at these things, guys. Okay. What is OLAP stand for, Niharika? If you're still there online.
Online
Online
API, sir.
Analytical processing.
Yes, sir. Online analytical processing on online.
That's where Azure Synapse Analytics is coming to our rescue.
Yes.
Okay, and we'll spend some good amount of time in the coming up days. Then we have non-relational data, semi-structured and unstructured data. And JSON, what does JSON stand for, Niharika?
I didn't get it, sir.
JavaScript object notation.
Yes.
Good job. And let's see then, so in other words, the data can be stored in the form of JSON or key and values. When we discuss about key and value, what comes to your mind, Niharika?
Dictionary.
As simple as that. It's nothing but a dictionary, like a dictionary. So that is also semi-structured. And again, Cosmos DB. That's our NoSQL database here. Semi-structured column families, this is like HBase. And again, you can store your data in the form of column families in Azure Cosmos DB using the Cassandra API. So in other words, HBase and Cassandra are competitors. So in other words, this is indirectly taking the concepts of Cassandra and using it in Cosmos DB. That's what is going on. Then graph data. Graph data is Azure Cosmos DB Gremlin API. Now, do you remember what is an example of graph data, Niharika? Graph data is your Facebook data, your LinkedIn data, who's connected to who's connected to whom, and so on. So using these connections, using the Facebook likes, Facebook messages, and things like that, we can plot it in the form of a graph. That's what the graph-like data. So we can also store our data in the form of a graph-like data in Cosmos DB, more precisely. It is allowing us to store our data in whatever formats is. It may change from use case to use case, or maybe project to project also, guys. Okay. Then we have unstructured data. This is the seas and oceans. Actually, these are the seas. And this is the oceans of the world. Most of the data is unstructured, videos, audios, and things like that. Niharika, by any chance, do you recall what is block storage?
Blob, unstructured, sir, blob.
Unstructured, more precisely, the data is getting saved behind the scenes in the form of blocks. If you guys recall in Hadoop, we discussed our data is getting split, distributed, and replicated. SDR is our mantra. Even in a traditional hard drive, behind the scenes, our files are getting split and distributed. Not on multiple, but they are getting split into multiple blocks, and they're getting distributed in multiple locations of the hard drive. Because we are talking in terms of blocks, that is referred as block storage. That is nothing but the disk. What is file storage, Niharika?
Where the files are stored in that cloud.
Where do you save them?
Cloud, Azure cloud.
The network drives and things like that. Generally, on your laptops and things like that, they give you a common location where they allow you to put all your project documents and things like that in a common location. That location is nothing but a server. It's acting like a server. That is nothing but the file storage. So we can, on Azure cloud, we can create these network drives and access, map them onto our laptops and computers. Okay. And what do you think is object storage, Niharika? It's a tough one.
It is unstructured data like videos, audios, or images.
Okay,
are stored in that.
It is also that one, but more precisely, the objects, instead of converting them into records and storing them in a relational database, they can be stored as objects themselves. An object in an application can be stored as an object itself. That is what is referred as object storage. That's a slightly tough one. For you guys at the stage, you're probably not coming across object storage, but that's something to be kept in mind. Okay. Everybody okay with this slide, guys? Quick yes, please. Pardon me. Okay, so there is Azure Cosmos DB in detail. Let's dig into it. It is fully managed. Again, Azure takes care of it. All the updates, backups, and things like that. It's a NoSQL database, not only SQL. It's a global database. It automatically replicates data across multiple regions. So in other words, it's like our HBase. It is the answer of Microsoft to HBase. It is automatically replicating, and it is single-digit millisecond response time. So in other words, this is faster than a traditional database. And 5.9 availability. 5.9's availability is much more lower. I think it's 4.5 minutes downtime. 4.5 minutes downtime per month, I think is what I recall, guys, okay, roughly. And automatic scaling, storage, and compute, just like Hadoop, behind the scenes, it is scaling. It is adding more servers. It is reducing it. It is adding the storage. It is adding the compute. It is reducing it. If there is less, it is also reducing the computation servers. And it is serverless. By any chance, do you remember what is serverless, Niharika? 26 seconds. Good, Lavanya. 5 nines availability is 20. 6
some
seconds.
minimum.
Just an FYI. Sorry, Niharika. What is serverless?
Serverless means we will use at how much time we want, and remaining time it is cloud. It is used by the cloud
Good.
to other works.
Good. So, what is the main advantage of it?
Cost reducing.
Pay only for what you use. If in a day, if you're renting the Starbucks coffee, whether we use it or not, we're paying the full cost. Whereas in serverless, it's like saying, hey, if I'm going to use only 1 hour in certain days and maybe 10 hours in certain days, we will only pay for 1 hour and 10 hours. Right, Niharika?
Yes, sir. Right.
The main advantage is the cost, guys, okay? Multi-region rights. Now, this is a tough one, Niharika. By any chance, do you remember what is multi-region right? And maybe see if you're able to recall a little bit about HBase and see if that helps you understand this one. What is multi-region right?
Multi-region means we can access in different places.
Different places, and each place is a region. So our data is not only available in one region, but it's in multiple regions, multiple geographies. So what is the main advantage of that?
Like we can access it anywhere, from where.
True.
For example, one client is here and another client is working in some other region, so we can access in the both places.
No.
That's the advantage.
That is CDN. That is cloud distributed network. I'm sorry, content distributed network. That is. This is multi-region means if in a region the server fails, we're able to get it from another data center, another zone, another region is what it is, another geography. Catching it.
Got it.
This is about fault tolerance. This is more close to Hadoop. So data distribution to any region with the click of a button, your app doesn't need to be paused or redeployed to add or remove a region. In other words, when we save the data to Cosmos DB, Cosmos is saving it to multiple regions. In other words, all these things are automatically being provided by the Cosmos DB. We don't have to write the code. We don't have to do anything. They're automatically being taken care of. Okay, and structure. Azure Cosmos accounts database container items. So at the time of creating Cosmos accounts, we first create a database, then we create a container, and then we try to create an item. That is the process we'll follow. That will do it in the labs, guys. Okay, but let me cover a little bit of theory. Gentlemen, ladies, everybody okay with this slide? Quick yes, please. Remember, every one line, every one point is going to translate into a question in your certification, guys. All right. And Cosmos DB APIs, which means when we save the data in Cosmos DB, if imagine Pravalika is an expert in SQL, then what she can do is she can write SQL-based commands or SQL-like commands, and she can access the data. If the data is stored in the form of XML, which is like a semi-structured data, then we have MongoDB API. We can access it. So MongoDB API is like dictionary of dictionaries. You access the key, you get the value, then within the value, you see if there is a dictionary or if there's an array, and then you keep on nesting it. It's like dictionary of dictionaries. You access the nested keys and you try to access the values inside that. Okay, even a table. A table is nothing but a pure key and a value. This is also slightly similar to MongoDB. You just access it in the form of key and value. Ideal for moving existing Azure's table storage workloads, or in other words, traditionally what happens is the data, some of the data is generally getting stored here in the form of keys and values. And the rest of the data is stored in the form of denormalized data and things like that. Then Gremlin graph, store complex relationships between data. So back to LinkedIn, Pravalika is connected to Vinay. Vinay is connected to Vishweshwari. Maybe Pravalika may also be connected to Vishweshwari. Okay, so in other words, let's say here is Pravalika. She's connected to Vinay. And let's say here is Vinay is connected to Vishweshwari. So let's say, so here,
annotation is not visible, sir. Sketch is not visible.
Oh, sorry. Aren't you seeing those things? Strange. Here we go. Thank you. Sorry about that, guys. From that time I've been drawing these things. So here is Prabalika, here is Vinay, and here is what is called Vishweshwari. Cool. So let's say I come here, choose this. Prabalika is connected to Vinay. Vinay is connected to Vishweshwari. So maybe Prabalika is also connected to Vishweshwari, and Vishweshwari is also connected to Prabalika. What is that? That's a set of complex relationships. We can extend those relationships. What happens is, here we're taking a look at two. But what if you have hundreds and thousands of them? Then they get very, very complex. Okay, what is that? We have a graph. We can represent our data in the form of a graph and save them into Cosmos DB. And then we access the data using graph. Graphs is also again in terms of nodes and edges. We'll talk about that. The next comes the Cassandra. Cassandra is our HBase like data, where we have the column families. Column families can have hundreds, thousands, and millions of columns inside a column family. Traditional database will have 10, 20, or maybe 100 or 200, or maybe at the most 1,000 columns in a data warehouse world. Whereas column families can have millions and millions of columns. We store the data as columns, just like HBase, guys. Okay. We need a separate account for each of the type of the API. Okay, we'll see that in a bit. And let's say back here to the next one. Okay, so here is an example of let's say JSON document. Let's say stop it a moment. Let's say share it. Okay, back here, snap it, put this here. Let's see what else we have. Okay, so there is ID, there is username, the key and the value. The key and the value. And now, what is special about activity? Can anybody tell me? Amulya, can you come on the this one? Can you unmute yourself? Amulya. Okay, so this is in JavaScript object notation, a dictionary of dictionaries. These are the keys, and activity is a nested key, which is again having its own value. That is nothing but the JSON data. Okay, so Azure Cosmos DB, let's dig a little bit deep into it. See what we have. Single digit millisecond response times, even if you scale to petabytes of data with millions. So petabyte, again, 1 petabyte is 1,000 terabytes. In other words, again, I'll probably ask you, that's a certification question, guys, okay? It's 1,000 terabytes again, data with millions and millions of transactions per second. If it's hundreds and thousands, you go to database. If it is millions and millions, you come to the NoSQL, which is nothing but the Azure Cosmos DB. And horizontal scalability, remember, as the data is increasing, as the number of rows and records are increasing, just like HBase, Cosmos DB is automatically scaling out. It is increasing the number of servers and taking care of the stuff. Love about the Cosmos, that is the flexibility. So Cosmos DB takes case. What traditionally, where we need to write the code, we need to do these things manually. It is automatically taking care of it. That is what is the flexibility. Structure the data your application needs. So in traditional world, what is happening is certain use cases need the data to be stored in a JSON-like format. Certain use cases need graph-like data. So what do? You have the flexibility. You can store it as JSON, you can store it as key value, you can store it as graph-like data, or using column families and things like that. Let the structure evolve with time. Structure evolving with time means the schema is changing. The schema is changing means the columns. In a traditional database world, if you recall, what will happen is, if a table is added, then the number of columns will remain the same most of the time. 90–95% of the time, they remain the same. Here and there, they keep adding more columns. But in the world of unstructured data, what is happening is every second, You may want to add a column, you may want to change the structure of your tables in the database. What do? That is what we mean by structure is evolving, means structure is changing. Based on our requirements, the structure change, and in such cases, the traditional databases will fail. They will not be able to, we will not be able to come up with a good design. That's where the NoSQL comes to our rescue. Again, the mantra of NoSQL is going to be Cosmos DB in an Azure world. In a Hadoop world, it is H-based, guys, okay? It provides a variety of consistency levels. So yesterday we talked about strong consistency. We're yet to talk about eventual consistency. And we have statelessness, session-based consistency, and consistent prefix, okay? A couple of things which are generally we encounter in real world is the strong consistency versus the eventual consistency. That's what we'll talk in the coming up slides, guys. Everybody okay with the slide, please? Quick yes, please. Okay. And next one. Okay. So the structure of Cosmos DB. Within Cosmos DB, we have something called a database. And in an SQL world, we'll call that as a database. In a Cassandra world, we'll call that as a key space. Key space is like a table. It is nothing but a group of tables. MongoDB calls it as database. Gremlin calls it as database. The table is, for the most part, the key and values only. It's like a dictionary. It is slightly similar to the MongoDB, keys and values, more precisely on this one. Okay. Then we have a container. Container is, again, if you recall, virtual machines versus containers. Containers don't. Okay. So here the container is a group of tables. It's acting like a group of tables. And in the world of Cassandra, we're calling that as a table. In MongoDB, we're calling that as collection. Gremlin, we're calling that as a graph. And in a table world, we're just calling it as a table, guys. Okay. Then we have item. Items are nothing but the rows. Rows are the records within the thing. So just a little bit of terminology. We're coming. And now here comes a little complex part, the logical and the physical partitions. Okay. Each container is horizontally partitioned in an Azure region. So again, just like HBase, the data is getting split and it's distributed. Each distribution here, in Hadoop world, we call that as a block. Here we call that as a partition, or maybe a shard is what some people will call it. It is also distributed to all the Azure regions. So in other words, behind the scenes, the Azure guys are maintaining the Cosmos DB in multiple regions. So if you are unable to, if the data is unavailable in certain regions, we are automatically, Cosmos DB is automatically getting it from other regions of the world. Okay. Items in a container is divided into logical partitions. So items are nothing but the logical partitions. Logical partitions, nothing but the rows. Each row is referred as a logical partition. The partition key is nothing but a primary key. We've discussed yesterday the first normal form, second normal form, third normal form, and the primary keys and the foreign keys, guys. Amulya, are you there? Suresh, are you there, buddy? Okay. Lavanya, how about you? Oh, you're there. Okay, unmute yourself, buddy. Not able to unmute. back here, back here. Okay, so Cosmos DB takes care of categorizing logical partitions into physical partitions. Okay, physical partition is nothing but a partition with a group of rows and records. That is nothing but the logical partitions. So a little bit of terminology, it's nothing much, but behind the scenes, these physical partitions are like the blocks. Here, a table is getting split into different blocks. In the world of big data and Hadoop, the file which was getting split into different blocks, but here is a table is getting split into different blocks is what it is. It ensures high availability and durability. Again, we've talked about high availability. If it goes down at one place, it's automatically available at another place. Durability is we never lose the data. Okay, guys, everybody okay with this slide? Quick yes, please. Okay, moving to the next one. Let's see what we have here. Okay, so here is provision versus serverless. Provision is where you're renting the server Starbucks coffee completely for the entire month. Whereas here we only pay for what we use. Here also, that 1 month is also a model where we are paying for what we use, but serverless is much more normalized. So description, provision throughput in request units per second. Throughput again is measured in terms of CPU, memory, speed, hard drive, all those units. In other words, that is nothing but the performance. In serverless, no need to provision the capacity. In other words, you don't need to worry about the CPU, RAM, and other components. It is automatically taking care of the request. So here we say, I wanted 32 GB RAM, I want this much the vCore CPU and things like that is what we'll say. We'll come up with this one. Whereas when serverless model, we don't need to do that planning, that architectural planning. What are you built for? RUs, provision per hour. So every 1 hour that we use, we are getting paid for the storage and the computation. Here, it is per hour request units, consume plus storage. So here, whether you use it or not, you will pay. Usage does not matter, means. And here, if you're not using it, you're not paying. Only when you're using it or consuming it, you are paying. That is what is the serverless goal or objective, guys. Okay. When to use? When you have predictable traffic. If every day you're very sure you're going to get some traffic on an hourly basis and things like that, then we provision it. But if you're not sure to your coffee shop how many people are going to come, and you don't want to spend a lot of money, then that's fine. Intermittent, unpredictable traffic, only during festivals, only during certain times. Multiple regions, okay. So again, that is one advantage of it. So here only one region. So again, based on the requirements, it can be architected in a different way if we need a multi-region support here, but that is beyond the scope of this one, guys. Okay, we don't have to worry. Maximum storage per container. There is no limit. Okay, there is no limit. And serverless again 50 GB. So here 50 GB, that is more than enough, guys. Okay, these are for small streaming scenarios and things like that we use, and that's what it is. Then performance, less than 10 milliseconds for point reads and writes. And here also for points, it's almost, you get the same performance. In other words, whether you use a provision model or whether you use a serverless model. That's what it is, guys. Okay, everybody okay? So again, what are these questions which might be translated? We'll try to discuss about them in detail, but that's a quick this thing, guys. Okay, so let's see. Lavanya, are you there?
Yes, no.
Okay, let's see if you can take it. How can you increase the storage associated with the Azure Cosmos DB? That's a tough question. How do you think we can increase the storage? Tough question.
No idea, Naveen.
Understand. I understand that. Okay. Okay, maybe. So in other words, this is probably not the right time to ask these questions to you. We'll make a little progress. So put you on hold. So automatic scaling, serverless is automatic scaling. Based on the number of requests received and things like this, scaling will happen. And that's how the storage is getting increased from a general standpoint of cloud also, guys. Okay. What is the high level structure of storing data in Azure Cosmos DB? Again, that is in the labs we'll see later. When we create a Cosmos DB, we'll create a database, we'll create a container, and then we'll create a item. The container is nothing but acting like a table. The item is acting like a record. So database is a group of tables and a table is a group of records, is what you can think of. Okay. How are the items in a container divided into logical partitions? Well, using the partition key. So in other words, it is the Cosmos DB is using the primary key to divide the table, a group of records, into different. Auto scaling is auto scaling. It is automatically scaling out based on the number of rows, Niharika. As simple as that, just like Hadoop. If more data is there, more servers are automatically getting added and they're being maintained on the storage and they're being saved. Okay, you want to store data for a social networking app with complex relationships. What do you think, Lavanya? When we have complex relationships, will we store it in a graph-like data? Will we store it in a JSON-like data or a table-like data?
Graph-like
data. That's where Gremlin API comes in. So that is something we need to be familiar. Then you want SQL-based API for working with the documents. So in other words, that is a core SQL API. That's what is nothing but the SQL commands, the SQL language that we are referring it as API, application programming interface is what it stands for, guys. Okay. You want to move existing MongoDB workloads to Azure. Okay. So what kind of scenario do we use? A graph-like API, a core SQL API, or a MongoDB API? Well, that would be a MongoDB API. It should be pretty straightforward. MongoDB is nothing but a JSON. JSON is nothing but a dictionary of dictionaries and things like that. Okay, Lavanya?
Okay, Naveen.
Okay. So next, Azure Storage, we have already talked about this: relational data, non-relational data, semi-structured and unstructured data. So there is the different kinds of data redundancy. Local redundant storage, again, we have talked some time back about this. Is 3 synchronous copy in the same data center. In a data center, for every file is again saved in 3 copies. It is the least expensive and least availability. So if the data center fails, then we have all the 3 copies gone. Zone redundant means, remember, zone is a group of data centers. 3 synchronous copies in 3 zones, in 3 different zones. Then geo-redundant is locally redundant storage plus a synchronous copy, which means in the background, we are copying it to a secondary region. You first maintain in a single data center, then you copy it into another secondary region. Then geo-zone redundant is ZRS, which is these 3 synchronous copies in 3 zones, and then a synchronous copy, which is behind the scenes. We are copying it to another secondary region. That is geo-redundant. So that will be, because we are copying it in multiple servers, multiple data centers, it is comparatively more expensive than other things, guys. Everybody okay with the slide? Quick yes, please. Okay. Okay. So Lavanya, come online. We'll take a few questions here. Read the question and give me an answer.
All availability zones in an Azure region are present in the same data center. All availability zones. False.
Why false?
Because the data centers are in different regions. Separate data centers. in single zone.
Okay, more precisely, a zone is a group of data centers and
Yeah.
a region is a group of zones. So it's saying all zones in one region are present in, no, it is the data centers which are present in the zone, not the zone present in the data center. Okay. So false is the right answer. Let's see next one.
Availability zones in a region are connected through low latency links. True.
What does low latency mean?
High performance,
Very good.
less delay.
And why are they connected through high performance links? Less delay. Good one there. You answered it. Okay, so that should be true. Next one, read.
Which of these are advantages of regions? All.
Have you read them?
I think we performed this task before.
Okay, good one. You should read it again. But okay, high availability, low latency, and global footprint. Okay.
Azure SQL database is an example of platform as a service.
Why?
Database we have to configure, right? In PaaS.
You configure only. Is it installed for you or you have to install?
We have to install.
No. If you have to install, it becomes infrastructure as a service. They're installing it and giving it to you. You configure it and you write code.
Configure.
You only configure, you don't install it. Okay? It's a platform as a service. Okay, next.
Installing a SQL Server database manually in Windows Virtual Machine is classified. Windows Virtual Machines. I think infrastructure as a service. Manually in Windows. Infrastructure.
Very good. Okay, let's see. Okay, continue.
In platform as service, customer is responsible for database availability. False.
Why?
We just have to configure. We don't install or the availability. We are not responsible for it.
Very good. That is taken care of by the Azure cloud provider. Okay. And next one.
In platform as service, example Azure SQL database, the database administrator is responsible for upgrading OS. In past, we have to responsible for OS applications, right?
You tell me, you don't ask me.
False.
That's, I think, a true thing. Oh, sorry, false. Okay. In past, the database administrator is responsible for upgrading OS, for upgrading operating system. So false.
I think we have to upgrade the OS in past.
The OS should be installed and also the database should be installed, right? Database administrator. Okay, okay. All right, I'm not able to think much in regards to that, but okay. Continue.
Using infrastructure as service, Windows VM to run a database SQL server, database administrator is responsible for upgrading OS. No, false.
Okay, one moment, please. Okay, sorry about that. Okay, continue. Lavanya?
I said false. Let me know what is the answer.
When using IaaS, okay, so which means we rent the VM and we install the SQL Server. Are we also responsible? I think the answer is true. In IaaS, you have to do that. In PaaS, I think you don't do that. This is what it is. They do that. This is what it is. So let's say I come back here. True, yeah. So short answer is, if it is IaaS, we do it. If it is PaaS, we don't do it. Database administrator will be the administrator of the cloud. Whereas in IaaS, the database administrator is going to be for our side. We will install SQL Server, we may install MySQL, we may install Oracle or maybe Postgres. What we install is dependent on us. Catching it, Lavanya. That's why it's true.
So here the database administrator is we, right?
Yeah. In IaaS, we are just renting the VM, and in that one, we manually take care of that. In platform as service, we don't do that. The database administrator will be cloud's administrator, more precisely. There's a little bit of gap in asking the question here. I think definitely they'll be giving us more information. But let's say, read.
You want to set up an SQL Server database in Azure. You want to minimize operational overheads. Which of these Azure databases would you recommend?
Read the answers.
Azure Cosmos DB MongoDB API, Azure Table Storage, SQL Server on Windows Virtual Machine, Azure SQL Database. Azure SQL Database?
Why?
We want to set up SQL Server database. Operational overhead.
What do you think is the meaning of operational overhead? Lot of operations. You have to take care of all the operational, everything related to that. So Azure SQL database is again platform as service. All the operations are taken care of by the cloud provider. You don't worry. Here they're saying an SQL Server database in Azure. SQL Server is not same as Cosmos DB. Table storage is not Cosmos DB, but it is either the option C or D, but more precisely it will be D, is what I'm thinking. We'll see the answer in a moment. The C is not an answer because SQL Server on virtual machine means again, we may have to install SQL Server. So let's see. So I think it is Azure SQL database. That's why I think the answer I have not taken. It's pretty straightforward, Azure SQL database. Okay, Lavanya?
Okay.
Okay, continue.
Which of these are some of the benefits of using platform as service Azure SQL database? No hardware management, automatic backups, automatic installation of latest version, all of the above. All of the above?
Good. So we don't need to maintain the hardware. The backups are taken by the cloud. The installation is also taken care of by the cloud. And the hardware is also taken care of by the cloud. So that should be all of the above. Continue.
You are migrating on an on-premises SQL Server database to Azure SQL database. You can reuse your existing enterprise's license for SQL Server. True.
Why?
We are migrating. The license will be same. Isn't it?
Okay.
On-premises to Azure, I think it's false.
And why?
Here, the private on-premises means it's private, right? The private database is migrating into Azure SQL database. You can reuse your existing enterprise license for a SQL Server.
Okay, I think the answer is true. The reason is Microsoft is allowing other companies to get onto their cloud. So if they have already purchased a license, they're allowing it, as simple as that. They are also helping their clients, the other businesses, not pay unnecessarily. If you already have an item that you're using on premise, a license, then you just use the same license is what it really means. That's why it's a true. Okay.
Okay.
One more. Okay. Okay. Continue.
You are building an online e-ticketing platform, issuing tickets to major sports events. You are using Azure PostgreSQL as the backend database. What type of processing is your application using? Batch processing, online analytical processing, online transaction processing. Online transaction processing.
So you're building an online e-ticketing platform issuing tickets to major sports events. So you're saying it's online transaction. Why?
E-ticketing platform, and there are more transactions will be happening.
So, okay. So in other words, what's a transaction? How do you define a transaction?
Row-wise storage.
Good. Rows records is nothing but the transaction data. So if let's say Niharika purchased a ticket, we will insert Niharika's data into one table, which seats she purchased, which location of the stadium and things like that will be saved into another table. So these are multiple rows of multiple records of multiple, or in other words, these are transactional data. That is online transactional processing, as simple as that. Do you remember what is batch processing, Lavanya?
Batch processing. Is it related to bank statement?
Good. And what about it?
Delay in response.
Can you
What?
explain?
There is a delay in response regarding the batch processing.
Why?
There will be more process done backend.
So in other words, bank statement is not something you want every day.
Yeah.
Once in a month, we will pick it up. And we will take maybe a bunch of customers. It could be 100,000 or 1 million customers. That is referred as a batch. There is a delay and you're taking a batch of them and we are processing them. That is what is batch processing, okay? Okay, continue.
Your application needs to store unstructured data like images and videos. Which type of data store do you recommend? Images and key value, columnar, document, object. It's object.
What is your answer?
Object.
Why?
It takes the images and videos and stores it in the type of file.
Okay, what is document storage?
Document is semi-structured.
Example?
Resume.
Resume is semi-structured. Okay, more precisely, document is JSON data. Okay.
Oh, okay.
And what do you think is columnar storage?
OLAP.
Columnar is columns and rows. Document is dictionary like data. Columnar is columns and rows. Are you able to columns, rows, column families is columnar? Okay.
Okay.
What do you think is key value?
It's a dictionary type.
It's also like a dictionary.
Yeah.
In document, there can be nested dictionaries. In key value, you generally store one key and one value. You don't necessarily have nested. You can if you want to, but generally it is just one key and one value. Okay. So I think the answer is object oriented. Okay.
Azure Cosmos DB is a storage non-relational NoSQL database.
What does NoSQL stand for?
Not non-SQL, which is not SQL.
Not only SQL.
Not only SQL.
What is meaning of storage account?
Storage account.
Good one, Niharika. So storage account means in Azure Cloud World, we're calling that as object storage, file storage, and disk storage. Catching it, Lavanya?
Yes.
What is relational database?
SQL, which is structured.
It is nothing but tables and columns, the structured data. Why do we call it structured, Lavanya?
It has rows and columns.
And it has column names, it has data types, it has primary key, it has foreign key. What is primary key?
Primary key, which is the ID. ID of instructor. Unique. The ID which is
like
provided to
good. It
each.
is like the main ID. What is foreign key?
Instructor ID, which is primary ID. The primary ID, which is called foreign ID.
Primary ID is the primary key.
Okay.
Secondary ID is nothing but the foreign key. So if you have instructor and course, or let's take person and cars, each person has multiple cars. So in cars table, we store person ID from person's table. What is person ID? Person ID is a primary key in person's table. In cars, we will have cars ID as the primary key, but apart from the car ID, to know to which person a car belongs to, we also save the person ID. Right, Lavanya? Will you catch it, Lavanya?
The person ID is foreign key.
Oh, okay. Let me explain that to you. Let's stop this. Okay. So let's say here is persons, here is cars. Okay, in persons, we have person ID. Here's person name. So use this one. Here is person name, person ID and person name. Okay, then in cars table, we have cars ID. But we always need to know to which person a car belongs to. So we store also the person ID here. What is person ID? This person ID is nothing but it's a primary key in the person's table. Okay, what is it? That is like a secondary ID in this table. The primary ID is going to be car ID. The person ID is acting like a secondary ID. That is called a foreign key. A foreign key is generally a primary key in another table. Catching it, Lavanya?
Yeah.
So every time we have a car, we know to which person that car belongs to. That's why we track the person ID. This is a group of tables together. They are your database. So database is a group of tables. Catching it?
Yes.
Okay. So read, continue.
Prefer relational databases when Strong transactional consistency guarantees are needed. Strong transactional consistency guarantees are
That's a tough question.
I think false. We can easily access by using relational databases.
We can easily access. What do you think a strong transaction means?
Strong transaction.
That's a tough question. Which means strong transactions. Do you think the relational database is used for transactions?
No,
Then what is it used for?
storing the data.
What is a transaction?
Which is semi-structured data.
A transaction can be a single record or group of records. Is a database used for storing a group of records? I think that's an absolute yes.
Yes.
It is strictly transaction. That is only when we use a database. If it is analysis, we don't use a database, we use a NoSQL. Something I want you to manually remember. Okay, fair enough. So
Okay,
transactions can be a single record or group of records. And when we are when we are saving all these rows and records to the database, we want to be very confident that the confidence is nothing but we are strong. Confidently store the transactional data so that it is consistent, which means whatever you saved is shown. If you save Niharika as a Tesla car today and tomorrow you ask the database and it is giving you Tata car, not Tesla car, then that is not consistent. That is incorrect data. It is not consistent. Okay, there's a little bit more depth. We can go into the consistency guarantee. We'll also discuss some more, but that is a true statement. Okay, next one.
Your application requires to store JSON document data. Which of these documents would you recommend? JSON list of dictionaries. Cosmos DB.
Good. Why Cosmos DB?
It's unstructured. JSON means dictionary of dictionaries.
Is JSON structured?
No, semi-structured.
Good. And
It
in
is
Cosmos DB, we can say semi-structured data. Like Mongo, using the Mongo API, we can retrieve the data. It allows you to store the data in JSON. And what are the other formats it will allow you to save in?
key value, column family, graph.
Graph, as simple as that. So that's why it should be Cosmos DB. And what kind of data is stored in Azure SQL database?
Relational, structured.
Relation means?
Structured data.
Means?
Which contains columns, rows.
Purely rows and columns, as simple as that. What do you think is Azure Synapse?
Synapse is column storage.
And it is Microsoft's answer for Hive. Whatever we can do in Hive, we are generally doing it in Azure Synapse, okay? And what is Azure Files?
Files.
Which is Azure File Storage.
Network drive.
File storage example is like network drive. Okay, next.
A key value stored can be used to complex relations between data.
Why?
It's like dictionary. Compared to this, I'm thinking it's second one.
Okay, it is used for storing user session data. For complex relations data, we use graph data, not key value. Key value is a simple key and a simple value, one key and one value. User
Yes.
session, this is a slightly advanced question. You probably don't know what is session data, but for complex relationships, it's graph data. Okay, Lavanya?
Okay, Naveen.
Okay.
Which of these services offers an in-memory database? In-memory. Second one,
Why?
which are fast, catchy.
Because that is the name of that database. What does in-memory database mean?
RAM database.
The database they're maintaining in the RAM. The
Yeah.
data is being maintained in the RAM. It may be a group of rows or maybe the complete database is just maintained in high-powered servers and things like that. For what is the main advantage of in-memory database, Lavanya?
We can fastliness.
What?
We can access with limited of the delay is very less.
Okay, in
Fastness.
other words, it is faster.
Yeah.
As simple as that. Because getting the data from RAM is much more faster than getting the data from the drive. Okay.
Prefer relational databases when database schema is non-mandatory. Schema changes. False.
When data schema is not mandatory means?
Schema, number of columns.
Data schema means the columns, the data types, the primary keys, the foreign keys, the relationships, and the constraints. What do you think is the meaning of relationship?
Relation.
Relationship.
The relation of columns and rows.
Okay, relationship means the primary, the parent and the child tables. For
Okay.
example, a person has many cars. So person will become the parent and cars will become the child. Okay. So I think here the answer is false. When database schema is not necessary, relational databases must require a database schema. In other words, you need to give the schema, which is the column names, the data types, the primary keys, and things like that. In analytical processing and unstructured data, those are not mandatory. Catching it, Lavanya?
Yes.
Okay. Let's take a short 10, maybe 12:27, 30. Let's take a break till 12:35, guys.
కడగమని చెప్పు వాడిని.
ఇది అమ్మ ఉంది కదా ఫస్ట్ ఆవల్ జీలకర్ర నూనె కాయిన తర్వాత ఆవల్ జీలకర్ర అది ఎరగబెట్టినాక చేస్తాం తర్వాత కరేపాకు అంతే కుక్కర్లోకి పసుపు వేసాము పసుపు ఎరగడ్డ టమాటాలు పచ్చిమిరపకాయలు
Sorry about that. Let's start. The scores of the coding test. Okay. Yeah, do that, Nihaka. And let's see, move on to the next one. Neha, Lavanya, are you there?
Yes, Naveen.
Okay, take a shot.
Azure SQL database is an example of platform as service.
Okay, should be pretty straightforward. Next one.
Normalization helps in avoiding data duplication across multiple tables. True.
What is duplication?
Replications. Normalization creates data inconsistency. Yeah, true.
Why?
Is inconsistency means the data without duplicates.
So let's say you stored Niharika as a Tesla car. We stored Niharika in person, car in and a cars, Tesla in cars table. Inconsistent means again you're storing Niharika has Tata. So now cars not only has Tesla but also Tata. But she has only Tesla. Understanding, Lavanya? Data inconsistency here can be thought of as data error.
Okay.
Okay, so normalizing creates, it's a false. Oh, I see. Data, no. I think that should be true, right? Chi. My bad. Yeah. Does not create data inconsistency.
Yeah.
So it's a false is good. Okay, continue.
Indexes help you to query data efficiently. Yes.
What do indexes do?
It gives the particular row of data.
Good answer.
In a clustered index, data is stored in a random order. In clustered index, the data stored in the order of index key values, right? So false.
Yeah. More precisely, the opposite is true. What do you think is opposite?
Data is stored in order.
In other words, in a clustered index, data is stored in a sorted order.
Okay.
As simple as that. It is not a random order, but it is a sorted order. Okay.
You can create multiple clustered indices for one table. Yeah. True.
Multiple clustered indices. Okay, let's see. It's a false.
False.
So you can create only one clustered index. You can create multiple non-clustered indices, I think is what is true. So that's the reason it is false.
True.
So that's true. You can create multiple.
What is the difference between clustered indices and non-clustered?
So clustered index means it's a sorted index. Non-clustered means it's non-sorted.
So we can create multiple
True.
random.
I think somewhere I have an example coming up. We'll see that one. Okay.
Assuming that course is a table name and the user one is a database user, grant select on course to user one is an example of assuming. It's a data query language.
Granting select on course. Okay, I think it should be data control language because you're controlling the permissions there. But what do you think is DML?
Insert, update, delete, manipulation.
Good. What is DDL?
It's like creating, dropping, altering.
Okay, data definition language is where you're creating the table and dropping the table. What is data query language? What does query remind you of?
Query means it's nothing but SQL. Storage.
Data query means you're issuing the select commands, Lavanya. Selecting is where you're filtering and querying, okay? So granting select means it is controlling the permission. That should be DCL, data control language. Okay?
Okay.
Okay. Continue.
Inserting a new row in a table, insert into course values is an example of data manipulation language. Yes. True.
Insert, update, delete are data manipulation language. That is true. Okay.
Select from codes where ID equals to DP 900 is an example of query language. Data query. It's like filtering.
Yeah. Select is your querying. So that is data query language. Okay. Can we just discuss?
Create database. Use your test DB is an example of create means DDL, data definition language.
Good.
Which of these is a virtual table representing content based on the result set of a query? You can join multiple tables in the query, and or have calculated columns, stored procedure, view, clustered index, schema.
Any chance do you remember?
Calculated virtual view.
Good. We have not discussed about stored procedures, views. I think we discussed yesterday. They act like virtual tables, as simple as that. That is what is there. Definition: clustered index is a sorted index. What is schema?
Column names and data types.
Pardon me?
Column names and data types.
As simple as that. So there should be a view. Okay.
Which of the following allows you to join data from a SQL server instance using TSQL with external tables such as SQL Server, Oracle, Teradata, MongoDB, Hadoop cluster? Join data from SQL Server instance using TSQL.
This is a tough question. For now, I will say you manually remember this, Lavanya. Polybase is used. Polybase is like a SQL. We use SQL only to transfer the data from other databases into SQL Server. So that will be the Polybase. Okay.
A key value store is mostly commonly used for a key value, session data. Complex is graph.
Lavanya,
First one,
so use the session. We just discussed about this. What do
Yeah.
we use for complex relationships?
graphs. For
Okay.
transactions, which of these data stores can be used to store complex relationships between data? First one,
What is Azure table used for?
to store the data in table form.
Okay. Blob storage is for
Unstructured data,
Postgres.
structured data.
Postgres is structured data. Azure table is more like key value. Okay.
Okay.
Blob is for unstructured data. Gremlin is your graph API. And what is Cosmos DB?
Semi-structured.
JSON, no SQL data. Okay. So that should be Cosmos. Okay. Next, continue.
You want to use a key value data store to store session data. Which of these Azure services would you recommend? Key value data storage. Second one,
Good. Azure Cosmos DB table API, that's used for key value.
Azure Cosmos DB table API supports multi-region writes. Multi-region writes. True.
Why do you think so?
Not remember. I'm not
Okay.
able to
Azure
remember.
Cosmos DB is behind the scenes. It's just working like Hadoop, where it is automatically storing into multiple regions. It's replicating the data into multiple regions. That is something which is providing. And table DB, you can, writes means you're storing the data, you're writing the data. And it is automatically the key and the values, and that is what it is. We have just read that it is used for millions of transactions per second. Transactions is nothing but keys and values, writing the keys and values, millions. So what is that? That is very intensive writes. So that should be a true. It is not only millions of transactions, but it is also making a backup of them in multiple regions. That is the functionality or the features of the Azure Cosmos DB. Okay.
Okay. Your application requires to store JSON document data. Which of these databases would you recommend? JSON. It's already done. First one.
What's your answer?
First one, Azure Cosmos DB.
Okay. Why Cosmos?
Cosmos. JSON is unstructured data, so
JSON is?
I mean semi-structured. So the correct one is Cosmos DB.
So again, repeatedly we've been saying that Cosmos DB is meant for
No,
SQL,
not
JSON,
only
graph-like data and things like that. What do you think is Synapse?
videos, images.
No, that is something like Hive is what it is. It's end-to-end analytics. We haven't discussed much about it. We'll discuss it in the coming up months. But for now, Cosmos is your focus. Okay, that's Cosmos DB. Is that?
Azure Cosmos DB is a non-relational or no SQL database.
Good.
Which of these services is suitable for existing Azure table storage workloads that require multi-region write capability? First one.
Suitable for existing Azure table storage workloads that require shouldn't it be all of the above? Cosmos table API, Cosmos Gremlin, okay. Cosmos Cassandra, okay. Interesting, all right, okay. We'll go with table API, maybe. Table, we store the data in the form of table API, and then again, they will try to resave it into Gremlin or maybe Cassandra. Okay, guys, let's maybe call it Cosmos Table API.
Which of these is a column family database? Column family. Cassandra.
And why?
It's like HBase.
Good answer. And
Column
what is the column
storage.
family?
Naveen?
What is column family?
The data is stored in column. Data storage in column.
So column family is a group of columns. It's like a table. It's a columnar database. By any chance, do you remember what is a columnar database, Lavanya? The hint is in the question.
It's a column row structure.
Good answer. It is columnar. Here the data is not stored as rows, but here the data is stored as columns. Okay.
Okay.
Let's see, what was it? So column family is Cassandra. Okay, the good one. Okay, continue.
Azure Cosmos DB Zerlium, Zerlium API graph database can be queried using Gremlin language. I think it's maybe true.
Why?
Gremlin language, it's quite using Gremlin database.
Because
You
it's
can
in the
point.
name. It's in the name, Lavanya.
Yeah,
As simple as that. Okay.
you are building an application to detect money laundering. You want to identify and store relationships between different transactions. Which of these databases would you recommend? First one? No. Third one,
Why?
transaction. It's transaction list.
Others, any hints to Lavanya, guys? Anybody?
Yeah. MongoDB. Great. Database. Relationships.
Explain.
Okay. MongoDB is nothing but JSON script. JSON script is nothing but dictionary. So the next dictionary relationships.
Okay. I think the answer is Cosmos Gremlin API. I think we've been repeatedly saying when we are storing complex relationships, we use the graph-like API, right? So I think there should be Gremlin. That's not Cosmos. It is nested relationships, but complex relationships is Cosmos Gremlin. Okay, it's graph-like data.
What is the difference between first one and third one, Naveen?
That need not necessarily be complex. Nested dictionaries need not necessarily be complex. What you're asking is a good question. You can also store it in the form of a JSON. But graphs data has been especially designed for scenarios where you have complex relationships. MongoDB is designed for anything and everything. Graph data is only when you have complex scenarios, complex relationships, that's when graph comes into picture. Okay?
Okay.
Okay.
What are the two users of data visualization? Each correct answer presents a complete solution. Each implement machine learning to predict future values. Inconsistently implement business logic across reports. Communicate the significance of data. Represent trends and patterns over time. Data visualization users.
We have not talked about visualization. We'll be talking about it, but take a quick guess, Lavanya.
B&D option. A&D?
Machine learning, you guys don't know. Machine learning is used for prediction. Again, we'll talk about it. Consistently implement business logic. Do you have any idea what is business logic?
The logic which is used in business.
As simple as that. Business logic is logic you write in the code. Those are nothing but the rules. And when you're writing the rules, that is not visualization. Okay. Communicate the significance of the data. So this you'll be able to understand when we look at an example, but that is the right answer. C will be the right answer. It is and giving us an idea or a picture of the data visualization. So significance of the data, it represents the trends and the patterns over time. That is also what it is meant for. So I think the answer is C and D. Let me see if I have it. That is C and D. And we'll discuss about visualization. So we'll not discuss much. Okay. These are also some of the topics we're going to discuss, but let me see. Let me pause the screen here for one moment. Or I'll stop it here for one moment. Let me come back here. Oops, pardon me. Okay. So I guess let me come back here. Okay, there are a few questions. Okay, let's do this, guys. I think I will first cover the data visualization, the data analytics part. They'll give you a touch of it, and then we'll proceed from here. For that, I need to make a few minor changes. What I'll do is, it's right now 1:12. Let's take a break till 2 p.m. and we'll continue from 2, guys. You guys go ahead and take a lunch break and come back, okay? Everybody with me? Quick yes, please. Thank you, guys. Lavanya, could you make me the host, please? Thank you, Lavanya. Give me one moment, guys. I'm bringing up my screen. Okay. Sharing the screen. Okay. That's what we have. So we'll go over a few definitions of some of the things that we have already discussed. So let me stop this one. Okay, sharing it again. This one. Sharing it again. There you go. Back here. Okay, so data analytics, the goal of data analytics is to convert the raw data or data into intelligence. What is the meaning of that, guys? Imagine we have a few cricket data of a few cricket matches. And let's say there's a cricket match tomorrow between India and England. So what can we do with the data? Well, we can build a model which will predict if India is going to win or not, if England is going to win or not. Okay, based on the prediction, maybe Indian team can make an adjustment in their batting and bowling and things like that. A prediction is a prediction. It is not a perfection. It's an approximation. But what we are doing is we are using data to make the prediction. Generally, if you ask any person who's an Indian, and if you were to ask them the question, if India will win or not, because they're an Indian, they would like to think and they would like to say that yes, India will win, even though England is a strong team. So what is the problem there? That is partiality. They are one-sided. A technical term for that is called bias. When we use the data to find such insights, such intelligence, there is less bias in it. Or in other words, we can try to reduce the bias or the one-sidedness in the data. A person may be one-sided, but if you take the last few matches of cricket and you try to build a model, then data may not necessarily, the whatever, whether India has won, whether England has won, depending on the data, the model is going to make a prediction. So there is comparatively less bias. That's a slightly much more deeper topic. But what we are trying to convey here is the data is the last maybe 10, 50 or maybe 100 cricket matches of data. You may have what is the run scored by the players, in which playgrounds, in which locations they played, what was the temperature. You may have many other factors like that. All that becomes the data. We can use this data to predict if India is going to win or not. What is that? That prediction is referred as intelligence. Today, that is where the money is. The data analytics is where the money is. Every business is trying to understand They're trying to look at their data and they're trying to understand. They're trying to predict their profits, revenues, loss, and many other things. In every use case, they are trying to integrate the capability of prediction. That is what the artificial intelligence is also about, guys. Okay. And what is that? That is what is intelligence. Data is like the land. On the land, there's a lot of sand and soil. Anybody can find the sand and soil. Very few people can find the gold in the land. What is gold? Gold is insights. Gold is intelligence. What is that? That is data analytics. We are analyzing the data to find our answers. Everybody with me so far, guys? Quick yes, please. Gentlemen, ladies, are you with me? Okay, so uncover the trends and discover meaningful information. So let's try to understand that, guys. Imagine here is an x-axis and a y-axis. Let's say that's a y-axis. Let's say here is an x-axis. Let's say here is day one. We're taking some stock prices. Let's take Microsoft on day one. Let's say day two, day three, and so on. Imagine Microsoft stock prices look like this. Let's also come back here, choose this one, choose this one. Let's say this is, we'll start here. Let's say this is 500. Here is 400. Here is 300. Here is 200 and so on. This is their stock price on the y-axis. Now, what is happening is, imagine on day one, choose this one, their stock price was 200 rupees or maybe $200 value. On day two, their stock price went up to 200 and let's say 50 or something. On day three, it went up here. So roughly, if we were to draw a line, okay, what's happening is the line would go like that. If you were to roughly connect those points, this is what is called a trend. Pardon me. Sorry about that. This is what is called a trend. And what do we try to do? We are now visualizing the data. We are trying to understand the trend. But let's say, imagine, let's take another company. For the sake of simplicity, let's take maybe Google. On day one, let us say it was 500 rupees, so maybe $500. And on day two, it is maybe 450. On day three, it is maybe 400 and things like that. So what is happening here is, notice it is coming down. The prices are coming down. What is this? This is called a trend. The Microsoft is a positive trend. It is increasing. As the days go by, my stock price is increasing and the Google stock price is decreasing. That is called a negative trend. And what is it? Discover meaningful information. In what way is the trend useful for us? The trend is indicating when, imagine a stockbroker, imagine Ganesh is into stocks and things like that. They're constantly visualizing the data of the stocks and they're trying to understand. It looks like on the fourth day, Microsoft may go up, is his prediction based on the last 3 days. And based on the last 3 days, maybe Google stock price might come down or maybe vice versa. Imagine Microsoft stock really went up on fourth day. That is a good decision. So if Ganesh purchased Microsoft stock, it will increase his profits. And if he were to purchase Google stocks and if it goes down, he will lose the money. So what is that? That is something which is useful, that is something helpful, and that is something meaningful. That is what is the objective of data analytics. What is it? That is in insights or intelligence. They help you understand the trends. The trends help you understand something meaningful inside the data. What is this one? The trends are there inside the data. You're discovering it. What do you discover? Something is inside. You discover. For example, if you go back to the example of the land. On the land, there's a lot of sand and soil. Anybody can easily find, say this is sand and soil. But very few people can find the gold in the land. The gold is there. What are we doing? We are not inventing. We are discovering the gold. What is it? That is the objective of the data analytics. The objective of the data analytics is to find the gold in the data. What is the gold in the data? The gold in the data is the meaningful information, is the insights of the intelligence. Everybody with me, guys. Quick yes, please. Okay. This is where all the money is there. Money is today, and all the money is today, guys. Okay. Now, next one, find new opportunities and identify weaknesses. So, what is finding new opportunities? Opportunities is where we are trying to understand. If a stock price is going to go up, then we'll buy the stock. That's a new opportunity for us to make the money. The business is also constantly trying to make the money so that they can survive. And identify weaknesses if there is any problem. So looks like Google stock is coming down. Maybe there is some problem in their company. So what's happening as a result of that? The stock prices are coming down. What do? Let us sell them. Is what it is. Okay. That is finding new opportunities and identifying weaknesses means it increases the efficiency and improves the customer satisfaction. Businesses are constantly trying to understand how to improve their business, how to improve their customer satisfaction. If they improve, if the customers are satisfied, they will come back to their business. That may be an e-commerce store or anything else. If the customers are not happy, if they are not satisfied, then they will not come back. So they're constantly trying to find. So what can we do? Well, we can use the data. Again, data can come to our rescue. And what's happening? That's what businesses are trying to do. For everything and anything, they are trying to look at the data and trying to understand different patterns, different meaningful indications, indicators, which will help their business. So why? They want to make appropriate or good business decisions. Business decisions from where? Business decisions from data. They want to be able to make how do? You take the data, you convert it into intelligence. How do you convert it into intelligence and insights? That is what is data analytics. You analyze it, use the machine learning, use the visualization, use the deep learning, natural language processing, computer vision. These are all the buzzwords. These are all the latest and the greatest things. Raw data can be from different sources. So in other words, data can be coming from different places. It can be customer purchases. So let's say Sharon purchased Reebok shoe, Ganesh purchased Nike shoe. For you, you might think they just purchased Reebok and Nike. But what are businesses doing? Businesses are taking the data. A person who purchases Reebok shoe, what might he purchase next? Versus a person who is purchasing Nike shoes, what might he purchase next? What are they doing? They're making a prediction. They're analyzing your data. How are they analyzing the data? They're looking at hundreds and thousands of customers who, after purchasing Reebok, what did they purchase? If majority of them who purchased Reebok shoes are purchasing Nike socks, what will happen? Next time Sharon goes to a Google or maybe any other website, they're giving a recommendation, they're giving an advertisement saying that, hey Sharon, you purchased Reebok shoes, here is the Nike socks, maybe this is what you might be interested in. And that might turn out to be true. Majority of them who are buying Reebok shoes are going for Nike socks. That could be true. What is that? That's an example of a pattern. That's an example of a trend also. Trends are nothing but the patterns. Okay, bank transactions. What is bank transactions? Some of the transactions are fraud. How do you know? What is happening? If you take credit card company, on a second by second basis, what is happening is hundreds, thousands, and millions of transactions are happening around the world. Now, what the credit card company try to do is they try to put up a call center, and then what they try to do, they try to analyze. If you have a few tens or hundreds of transactions, a call center with maybe 100 or 1,000 people can start analyzing your transactions. But when there are thousands and millions of transactions happening every 1 second, no matter how many people you have in your call center, you will not be able to analyze them. You will not be able to handle that amount of volume. So what do? That's where the machine learning is again coming to the rescue. They are taking these transactions, they're building a model. The model is predicting whether a transaction is a fraud or not. If it looks like a fraud, then that is forwarded to the call center. That is how the process is changing. Stock prices. Today, a lot of people are getting into stock pricing, algorithmic trading, and things like that. What are they doing? They're using the machine learning, data analytics techniques. The heart of data analytics is machine learning and deep learning. They're using the data analytics techniques to predict the stock prices. We can predict the weather. We can predict if a device, the IoT and things like that, the sensors, based on this data emitted by the sensors, we can predict if a device is going to fail or not. What is that? That is data analytics. After we collect the data, there is a lot of work happening in the world of data analytics. That is what the machine learning and the deep learning. This is the heart of not only the data analytics, this is the heart of artificial intelligence. So now, today, using these algorithms, it is they're making it look like robots can make a prediction, but it is actually they are using the algorithms to make a prediction, is what it is. Everybody with me, guys? Quick yes, please. Okay, so in the world of data analytics, there are a few steps, a process. The first step is called ingest. Ingest means you take the data, get the data. So here is the external world. That could be internet or that could be anything. You get the data from the external world. That process is called ingestion. What do? You store it to your data lake. The place where you store. You get the data from internet, that is the cloud, let's say, and then you store it into the data into your data lake. And then what do? Then we take the data, we process the data. What is processing? Processing is analyzing the data, trying to clean the data, applying different kinds of algorithms on the data, testing them, trying to understand what it is indicating, visualizing them. All that is called processing. So what is that? That is the next step. First step is you get the data. Second step is you process the data. Then, so at the time of storing the data, what can you do? You can, after you store the data, you visualize the data, you query the data. When do you query the data? Well, why do you query the data? To analyze the data, to understand the patterns in the data. What are patterns? Patterns are nothing but trends. It is nothing but it is giving you an indication of something meaningful happening in your data or in your business. What is this? That is the process. The place where imagine that is internet. We're getting the data from internet. Today, what businesses are doing is that one. They get the data from the cloud or the internet. They're trying to save into a data warehouse or maybe a data lake. And we'll try to understand what are the difference between data warehouse and data lake in a bit. Everybody with me, guys? Quick yes, please. So here is an example, guys. Decide future sales using past customer behavior. Back to Ganesh. Ganesh purchased Reebok shoes. Then he purchased Nike socks. What will he purchase next? Okay, so in other words, customers who are purchasing Reebok shoes followed by Nike socks, what are they going to do next? Well, what do? You predict it. Okay, let's say they're going to also purchase Adidas shoes. What is that? Well, you're predicting the sale of the next one. How much that might be? Will he purchase or not? Okay, that is an example. Faster diagnosis and treatment using patient history. So today, COVID, Corona, and things like that, what is happening is the pharmaceutical and the scientific industry. It is the data analytics which is coming to the rescue behind the scenes. A lot of data is being taken and they're trying to analyze, come up with different kinds of medicines, and they're doing lots of analysis on the database. That is and that is why we're getting all these vaccines faster. In other words, that is not the only reason. That is one of the most important reasons why we are able to get faster vaccines. There is a lot of work which is happening on the data. And what are they doing? They will help the patients. So based on a patient history, imagine a patient had a slight headache. followed by slight shoulder pain, followed by a slight maybe pain in the wrist or the thing. Okay, what is the next thing which could happen? Well, the next thing which could happen is he may get a heart attack. Based on these three, this is the history. They are predicting what might happen next. They are predicting. Okay, that is a very, very deep story, and a lot of work and research is being done on this kind of data, guys. That's where all the medical industry, medical domain is again focusing on. They're trying to predict. And what is the power, guys? The power is if they are able to understand for a few patients when a series of events like this is happening, what is happening to the patients, what can we do? They can understand, they can help millions and millions of patients who are having that kind of history, that kind of indicators, or that kind of signs and things like that. And being able to help millions of patients in other words, that is what is being done, guys. They're taking the heart attack data, they're taking the cancer data, they're building models out of it, which is predicting who are the next patients, who might be the patients who might be getting heart attack versus cancer and things like that. And then what will happen? They will call these guys and say, hey, you know, our data is indicating you might be in a slightly risky state. So why don't you take some precautions? Why don't you take some tests done and things like that? Everybody catching that, guys? Quick yes, please. Okay, so that is data analytics. And let's see, come back here. The next one is data analytics workflow. Let's see what that means, guys. A flow of work. Workflow is nothing but flow of work is one way, as a short and a sweet thing. Simple way of saying it, okay? Data ingestion is where we are capturing the data. Where we're getting the data, storing the data is data ingestion from various sources. So in other words, what businesses are doing is they're downloading the weather data. They're trying to see based on the weather, is the sales changing? What is that? Is there any pattern? Based on the weather, are the users purchasing some items? What is that? Is there any pattern? That's what they're trying to understand. So what do? The first step is get their data. What is that? That is called data ingestion. It's a process where you're acquiring the data. It's also called data acquisition. You first get that data. That might be on the internet. That might be in your own business databases, or it might be in any other forms, in log files and things like that. The next step is processing. Raw data is not suitable for querying. So we looked at JSON data. JSON data may not be directly suitable. Generally, what do? They take the JSON data, they convert it into a relational data, denormalized data. That is the data which is saved in a data warehouse. There is no normalization there. There's data duplication is okay. And what do? That's where they will write custom queries, very complex queries. They will try to filter. They will try to remove unnecessary data. They will use different kinds of aggregation operations, the count, sum, min, max, and many other kinds of things. And what is this? This is being done on big data. The moment this is being done on big data, that's where Hadoop comes in. That's where Spark comes in. What is that? That is called processing. They take the JSON data, they're converting into tabular data. What is that? That is called transformation. So that it is easier for querying. Everybody with me, guys? Quick yes, please. Pardon me. Gentlemen, ladies, are you with me? Quick yes, please. Okay, so data storage. Store. So once you get the data, that could be from the cloud, from the internet, or anywhere. Generally, what do? We can store it to the data warehouse, or we can store it to a lake. So data lake is unstructured data. Data warehouse is mostly structured data. That is a short and a sweet way of remembering it. Data querying is where we are running different kinds of select queries. Select queries is more in an SQL world. But the moment you try to get into slightly complex analytics, that's where Python comes to the picture. Python has a lot of algorithms, machine learning and deep learning algorithms. They perform complex analytics, complex mathematical, statistical, probability. These algorithms are nothing but a combination of mathematical, statistical, and probability operations which are happening on the data. How do? We use algorithms. What do algorithms perform that? That is what is analyzing the data. Then we visualize the data. Generally, what do data scientists do? They take the data, they try to visualize the data. Based on the visualizations, what do? They make some assumptions. Those are referred as hypotheses in a statistical world. They come up with different kinds of hypotheses. They try to perform hypothesis testing. Then they try to use the algorithms again. Algorithm is slightly advanced level of analysis and statistics is what it is, guys. Okay. So from the visualizations, they try to understand the data and they try to decide the next step. Why? They analyze the data so that they can make better decisions. The objective of visualizations is to make better decisions. The objective of storing the data, processing the data, analyzing the data is to help the business or whoever it is in making better decisions. So that could be a sports organization or that could be a business organization also. What do we do during this process? There are various ways of creating the dashboards. Again, that is where Python comes to your rescue. The basics of the Python that you have learned. Again, Python allows you to create dashboards very, very simply and easily, guys. They are nothing but charts, visualizations, and reports. They help you visualize them. They help business spot trends. Are there any patterns? Are there any outliers? Okay, what is an outlier? Outlier is something which is happens very rarely, let's see. Okay. I'm just trying to give you an example of an outlier, which is generally away from the normal behavior. Imagine most of the customers. Imagine customers when they purchase bread, they are purchasing milk, they are purchasing eggs, they are purchasing maybe butter or cheese. But there are a few customers, whenever they purchase bread, let's say they purchase beer. What is that? That is slightly abnormal. What is that? That is outlier. Everybody catching it, guys. What is that? That's a pattern. That's also an example of a pattern. Customers who purchase certain things are purchasing some strange things. From common patterns. That's a it can also be. It is a rare pattern. Rare pattern is what it is. What is hidden patterns? Hidden patterns is gold. If you take the land, what is gold? Gold is an example of a hidden pattern. It is there under the ground. What do we know? Well, we know it is hidden. And what is that? That pattern is something useful. Why is it special? Businesses today want to look at their land, which is the data, and they want to find these hidden patterns in their data. That's why the data scientists, all these guys are becoming the very most popular ones and so on, guys. Okay. Everybody with me? Quick yes. Everybody okay with this slide? Okay. So data analytics categories, there are different kinds of data analytics. Let's see what is descriptive analytics. Descriptive analytics tells you what's happening. So what is happening means, imagine, let's take cricket data. Imagine we have lost 50 or maybe 100 cricket matches of IPL data. We are looking at the data. What's happening? Well, what's happening is every time, let's say, in certain locations, Indian teams, let's say IPL, Indian team, or maybe Hyderabad Sunrisers. Whenever they play in Hyderabad, they win. But whenever they play in other locations, maybe they're not winning. Okay, what is that? That is something which is already happening. That already happened. We have taken the last 50 matches for the sake of simplicity. In that 50 matches, let us say 25 matches, Hyderabad won. Hyderabad Sunrisers has won the games. And what is this? This is something which already happened. What is that? That is what is called what's happening. That is called descriptive analytics based on historical and current data. So today we are Hyderabad Sunrisers is playing. That is current match, this data. And we have last 50 cricket matches of data, that is historical data. You monitor status and generate alerts. So it looks like if they're winning 25 games out of 50 games, that means their win rate is 50%. Okay, now in these 25 games, let us say 10 games were played in Hyderabad. And what is happening whenever they play in Hyderabad, all the 10 games they won. So what do? You can generate an alert. The next game is going to be in Hyderabad. So because the last 10 games when they played in Hyderabad, they won the game. That means there is a good chance or a probability. If they play in Hyderabad, they will win the game. Everybody catching the point, guys? Quick yes, please. So what are you doing? We're monitoring. And what are we doing? We're alerting, hey, we're observing something like this. That might be interesting. So what do you do generally? So in other words, that is, in the world of descriptive analytics, you generate reports and you try to understand what is happening. That is referred as descriptive analytics. Then diagnostic analytics is why is something happening. Now imagine a CEO of the Hyderabad Sunrisers is asking, why are we so good when we are playing in Hyderabad? Is it because it's a home ground or is there some other reason? Why are the Hyderabad Sunrisers always playing well in Hyderabad but not so well when they go outside? What is that? Now we are focusing on the why aspect of it. That is called diagnostic analytics. Descriptive analytics is, the mantra of descriptive analytics is what? The mantra of diagnostic analytics is why. Take the findings from the descriptive analytics and dig deeper. So what are we doing? We have taken the data which is coming out from descriptive analytics. We said 25 games, Hyderabad Sunrisers have won. And what did we observe? When they played in Hyderabad, they won. So we're taking that data and we are digging deeper. Now we are trying to understand what makes it, what makes these Sunrisers win the game when they play at Hyderabad. So we're trying to understand why they are winning. Okay, so now if you apply it at a business level, why did sales increase last month? It could be possible there was a festival. There was Dasara, there was Christmas, there was Deepavali. Is it because of the festival? What is that? That is a why. Why did the sales increase? Or maybe vice versa. Why are the sales low in Netherlands? In certain countries, if you take large organizations, large businesses, they are in multiple countries. In certain countries, we are performing well. In certain countries, we are not performing well. Why in certain countries we are not performing well? What is that? That is called diagnostic. The mantra of diagnostic analytics is why. Catching it, guys? Quick yes, please. Cool. Okay. Then comes the big one, the predictive analytics. This is where all the money is. So today the businesses are planning to investigate. They're trying to go much deeper. What will happen means this is the future. These two are looking at the history and they are trying to understand the history. Whereas this one is about the future. What is going to happen in the future? That is what is predictive analytics. Predictive analytics focuses more on the future. That is where the machine learning algorithms, the deep learning algorithms come to your rescue. They predict the probability based on the historical data, which means they take the past data, which is historical data, that could be 50 or maybe 100 cricket matches of data. And let's say, here is the data. From this data, what do? They will build a model. They will build a model. And what does the model do? The model can make a prediction. Is India going to win or not? Will India win or will India not? It will make a prediction and it will tell you, is it a yes or is it a no? Okay, what is this? We say, it will give you a probability. It will say there is a 90% probability India will win. There's a 10% probability India will lose. What is that? That's what data scientists do. Mitigate risk and identify opportunities. Imagine it is reverse. Imagine there is a 90% probability that India is going to lose. So now what do? You tell the coach, hey, our data is indicating that India is going to lose tomorrow. There's a 90% probability. So what can we do? Maybe we'll change the batsman order, the batting order. Maybe we'll take the bowling first rather than the batting first, or maybe vice versa. What are we doing? We are mitigating the risk. We're making some decisions which will reduce the risk of losing. Okay, we're trying to identify what are they, that also we can identify. What should we do? Should we take up the bowling first, or maybe the batting first? Okay, so if you apply that to business, what will be the future demand? We are selling a lot of Reebok shoes. Fortunately, this year we made some good Reebok. We sold good Reebok shoes. But what about the next year? How is the demand going to be? What do? You build a model. Based on what? Based on the data. Calculate the probability of something. So what does the model do? Model will answer your question yes or no. It will also give you the probability. Saying that, hey, there's a 10% or a 90% probability of something happening. What is it? That is what is called predictive analytics. Predictive analytics focuses more on the future. That is what is data science about. Data science, AI, all these things, why are they getting so popular? Because everybody is trying to understand in the future how their business is going to look like based on their existing data. That is what is predictive. You are predicting what is going to happen in the future. Whereas the descriptive and the diagnostic are focusing more on the history, predictive is focusing more on the future. Everybody understand that, guys? Quick yes, please. Gentlemen, ladies, are you all with me? Okay. Okay. So next comes prescriptive analytics. Even more advanced is prescriptive analytics. What actions should we take? What are we doing? Well, a friendly example or a friendly mantra is we have built a model from our 50 or 100 cricket matches of data. We're predicting is India is going to lose tomorrow for some reason. The model or the data is indicating India is going to lose. What do we do? Well, most of the time, majority of the time, India starts bowling first. So tomorrow we will change our decision to batting first. We are making a prediction. We are taking some action out of it. Okay, what is that? That is prescriptive analytics. We use the insights from predictive analytics and make data-driven decisions. Today, every business, what is happening is they have the top level management. They make the decisions. But what is the problem? They're all humans. What is the problem with humans? Humans may be one-sided. They might be biased. If they want to, so in their decision, it might not be, their decisions are all not, may not be fair. So what should we do? Whenever somebody is making an important decision, we will also verify with the data. It is not that the top level management is being removed. They will be there. But what will they do? Whatever the decisions that they are making will also go and base it on the data. Based on the data, we will try to verify if we are going to profit or if we are not going to profit. What is that? You're going to make a prediction. So based on data, every business is trying to make a decision. That is what is called data-driven decisions. Okay, guys, it's still in early stages. Means this is where all the businesses, as I say, they're investing the money. They're trying to understand different kinds of ways of how to make a prediction and things like that. What can I do to increase the probability of something being successful? That could be anything. That could be a course. That could be maybe business is going to be successful. We're going to, maybe a player is going to hit a century, or it could be anything and everything. If you have the data, all the businesses are trying to look into the data and find it, guys. Okay, that is prescriptive analytics. Prescriptive analytics is the next step of predictive analytics. Is one way to think of it. Next comes cognitive analytics. Cognitive analytics makes analytics tools to think like humans. Internally, cognitive analytics is also using the combination of the algorithms. They're also using the algorithms. They combine traditional analytics techniques with AI and ML features. So speech to text, converting speech to text, transcription, subtitles, text to speech, the reverse, vice versa, video analysis, trying to recognize different people, trying to understand the images, semantic analysis. If you go back, open your Gmail, you type in hello, it will show you, hello, how are you? It is automatically predicting. What is that? That is semantic analysis. Today, there are algorithms which will take textual data and they are about to predict what you are able to try next. What are they doing? They're looking at hundreds and thousands of and millions of people. When they types the similar words as you, what did they type? Based on that, they're making a prediction. That is what is called model building. That is what is, again, a slightly formal definition is cognitive analytics is where we're making the analytic tools look like human. Look like they have a human brain is one way. Okay, guys, everybody with me? Quick yes, please. Everybody okay with this slide? Google Assistant. Google Assistant is using AI. Is that cognitive? Yeah, that's cognitive analytics. Because it is taking your speech, it is converting it to text. The text is being given to algorithms behind the scenes. And based on what you have said, they're predicting and they're coming back to you. Okay, so back to a little bit of big data. Okay, these are slightly theoretical heavy, guys. So just bear with me. Give me one moment here. Okay, sorry about that, guys. Just went for a glass of water. So let's see what we have, guys. Big data, we have already discussed about big data and things like that, guys. But let's just quickly review. Whenever we talk about the big data, the mantra of big data, again, is the 3 V's. The 3 V's is nothing but the volume, the velocity, and the variety of the data. So what is happening is today, the data is growing exponentially. Why? Because today people, they are getting the data. More precisely, people are the businesses. Businesses are downloading the data from internet. Internet has become the new source of data. And when you download the data on a daily basis from internet, it is accumulating heavily. So again, 1 terabyte is 1000 GB. 1 petabyte is 1000 terabytes. 1 exabyte is 1000 petabytes. Again, a little bit of certification related questions. So every point is one something. Somehow they will translate this into a certification like question, guys. Just keep that in the mind. And what's happening is that is not just double or triple, but that is growing exponentially. That is what is the volume of the data. It is growing exponentially, guys. Okay. So what is happening is when you get the data not only from internet, but from different sources, generally the data within the database is structured. When you get the data from internet, it is semi-structured, it is unstructured data. It does not have any format. We may also have video data, audio data, and other kinds of data that becomes the variety of the data. That is the second V. The third V is the velocity. We may get small amounts of data. If you take the stock prices, every second the stocks are varying. That is called streaming data. Streaming data is small amounts of data coming in. And batch data you take, that is a bank statement. You take millions and millions of customers' data, the banks, the credit cards, and they process it during the end of the month. That is called batch processing. That is referred as the velocity. Velocities, it could be small amount of data in certain periods, or it could be very, very large amounts of data in the periods of time. That is the velocity, guys. So whenever people talk about big data, they will come back and they will talk a little bit about the 3 V's, guys. Okay, everybody with me? Quick yes, please. Okay, so some terms we need to be aware of is what is the difference between data warehouse and data lake, guys. Okay, data warehouse so is something which stores petabytes of data. How much is a petabyte? 1000 terabytes. And what can we do? We can perform computations. We can analyze the data. Data stored in a format ready for specific analysis means this is generally in data warehouse you store structured data. So let's say here is data. Data can be structured. Data can also be unstructured. In data warehouses, we generally store structured data. Then you try to analyze the data. It is process ready. So Teradata, BigQuery, Redshift, these are the different analytical solutions for the data warehouses, guys. Okay, so if you recall, data warehouse is like a super database. A super database is something like it is acting like a group of databases. So these are, the BigQuery is a Google solution for data warehouse. Redshift is an AWS solution for data warehouse. Azure Synapse is a Microsoft solution for data warehouse. Teradata is a separate company. Again, that is also a very, very popular data warehouse is what it is, guys. Okay, typically use specialized hardware. The data warehouses are generally performed on very, very expensive hardware. They don't use inexpensive, but very, very expensive hardware is what they use. So the cost is generally very, very high. Pardon me. Okay, then comes the data lake. Data lake is also used to store the data. It is also used to compute, which is nothing but process and analyze the data. And what do we do here? The data is raw data. Raw data is unstructured data. That could be semi-structured or that could be unstructured data. And we can compress the data for the storage reasons, because the data is growing exponentially. They try to compress the data. That is generally handled by the admins and things like that, but that is one of the advantage, guys. Okay, so it stores unstructured data. Typically, object storage is used as data lake. So we use object storage. We don't use file storage. We don't use table storage. We use object storage for data lake. Amazon S3, Google Cloud Storage. Amazon S3 is Amazon's. We can store the data in Amazon storage. We can store the data in Google Cloud, and Azure Data Lake Gen 2 is a Microsoft solution for storing the data in the data lake. Flexibility while saving cost. So here we don't need to use enterprise class servers. We can use commodity servers. So as a result of that, the cost will come down. Flexibility means we perform different kinds of transformations on the data. And we have different tools also to perform analysis on the data. It is ad hoc analysis. What comes to your mind? If you think it is something going to be which is helpful, useful, what can you do? You can analyze the data. And what do we mean by on demand? Well, that's where the data scientists are generally looking at the data. They get some ideas, they understand some patterns, and they say, let's perform this kind of analysis that is referred as ad hoc analysis. Okay. Analytics and intelligence services can directly read from data lake. So again, we can read the data from the data lake. And Azure Synapse Analytics is an end-to-end solution for performing the end-to-end analytics solution from Microsoft. BigQuery is a solution from Google to perform such kind of analysis, guys. Okay, everybody okay with this slide, guys? Quick yes, please. Okay, going a little bit deep. I would like one of you guys to go ahead and log into the Azure one more time and just kind of be ready, guys. We'll try to perform 1 or 2 labs and see if we have any issues and things like that. So going a little bit deep into the data warehouse things and things like that. There is something called dimensions and facts and star schemas and things like that. Let's try to simplify and understand them, guys. Okay. So notice here, here's a calendar key. Can anybody tell me what is this calendar key? What does it mean? When you look at the table, what is calendar key here? At this stage, it should be a simple answer only, guys, not a complex one. It is the primary key, as simple as that. Now notice the calendar key is sitting inside another table. So what is calendar key here? A foreign key. It's there like that. Okay. So we have calendar, we have store, we have sales fact table. That's a little bit of terminology of the data warehouse. They have fact and dimensions tables. And again, notice product key. This is products table, primary key, customer table, customer key. Now what they are doing is we are taking the primary keys of all those things and storing into this one. And what do they have? They have one column, which is the dollars sold. Maybe imagine Priyusha is a customer. On a particular day in a particular store, she purchased maybe Reebok or Nike, which is a product. And this is her customer ID. How much did she spend? Maybe that is maybe $20 or $30. So what is this? This is a fact table. What is this? Generally, the dimensions. These are dimensions tables and the fact table. So how do you structure the data for quick analysis in a data warehouse? that is star schema. This is like a star schema where you will call you here and there. You will hear something like a dimension or a fact table. For you guys, nobody will expect you to be perfect, but they will expect you to be have slight familiarity about these terms. Modeling approach most widely used by a relational data warehouse. So this is how the senior database administrators, senior database architects design the databases based on their requirements, based on their domain. One moment, guys. Sorry about that, guys. Suddenly there was some issue at my end. So sorry about that. So fact tables are quantitative data. What is quantitative data? Quantitative data means it is numerical data and data generated in a transactional system. It contains observations or events, sales orders, stock balances, temperatures. What is special about them? They're all numerical data. They're stored in these tables. That is nothing but quantitative data, as simple as that. Short and sweet, they are numerical data. So if you look at the keys or if you look at the dollar sold, that is all quantitative or numerical data. that is fact tables. Then dimension tables contain descriptive attributes. Descriptive means textual data also. That could be textual data. Your customer name, your store name, and your calendar, which day, and things like that could also be textual data. It is describing something about the customer. It is describing something about the table or the entity. The tables are the entities. Okay. Star schemas are denormalized and easier to query. So this is an example of denormalization. So generally, normalization separates everything into separate tables. That is the third normalization or normalization principle. But you take all these columns, all the important columns from all these tables, and you're plugging into one. That is called denormalization. So now in the reporting world, we don't go to four different tables and keep joining them. We go to one table, which is a fact table, and we try to keep querying this one. That's a lot of reads and things like that. That's where the data warehouse optimizes it. Internally, there are a lot of optimizations they do. They make it read only and things like that. Again, that is what is denormalized. And it makes the queries run faster, and more importantly, easier is what it is about. Everybody with me, guys? Quick yes, please. Okay. Okay. So again, Azure Synapse Analytics, there is a formal definition. It's an end-to-end analytics solution. It provides an end-to-end solution, analytics solution to be more precise, data integration plus enterprise data warehouse. It's like Hive. And what do? We analyze the data. We can also perform the machine learning and all that kind of algorithms. Okay. It creates SQL and Spark pools to analyze the data. So in other words, what it means is we can write SQL commands in Spark, in PySpark and SparkWord. So what is the advantage of that? We can analyze big data. Spark is for analyzing big data more precisely. How? Using SQL commands. And that is what the Azure Synapse Analytics helps us in. It is referred as an end-to-end analytics solution. So Azure Data Factory, fully managed serverless service. Okay, fully managed, we understand, taken care of by the Azure. Serverless, we understand. We only use for a certain time. And build complex data pipelines. What is data pipelines? Because pipeline means a group of steps. A group of steps is nothing but the input of one step is becoming the output of one step. Let's say this is step one. Step one. Let's say here is step two. Step two. So what is happening? The output of step one is becoming input to step two. And the output of step two may become input to another step. This is called pipeline. They are nothing but a group of steps where the output of one is becoming the input of the other step. And in the world of data analytics, a lot of steps, such steps we perform, we can put them together and we can automate them. That is what is pipelining. Then we have extract, transform, and load. We take the data. We have imagine, let's say, come here. Traditionally, what we have is, imagine this is database 1. This is database 2. These are all small databases. Yeah, one moment. Okay. So imagine we have 3 small databases. Now imagine here's a super database. What generally happens is we take the data from multiple databases. We try to load it up into a single database, into a single database, which is a data warehouse. So this process is called extracting. The first step is called extracting. So once you get the data from multiple tables and databases, what do? You temporarily load it into a certain table. Then and then you try to put only the required data here, which means first you extract the data, then you are trying to put it into a temporary table. This is where you make some changes. Once you make the changes, you're going to load it. So this is the step of transformation. This is the step of loading. That is what is called ETL. It is simply the process of extracting, transforming, and loading. And what is that? That is generally what happens in a data warehouse. In the world of data, it is extract, load, and transform. Okay, data lake can be thought of. So imagine here's the data lake. This is like a Hadoop word. What do? We generally take data from multiple data warehouses. So this is one data warehouse. Imagine here is another data warehouse. Imagine here is another data warehouse. And what do? We take this data from multiple data warehouses, we load it. We're taking the data that is extracting, then we are loading it into this one. Then based on the use case that we are working on, we want to, maybe we're working on a project or a use case where we are saying, we want to predict which transaction is a fraud transaction. What do? You transform the data. So here what we're doing is, the first step is we're extracting the data, then you just load it and keep it. Then based on the use case, you transform it. That is what is called extract, load, and transform. ELT comes in the world of big data. ETL comes in the world of data warehousing. Everybody with me, guys? Quick yes, please. Okay, Power BI, create visualizations around data, unify data and create BI reports and dashboards. So in other words, it's a powerful visualization tool. Power BI is a powerful visualization tool from Microsoft, and we use it to create reports and dashboards without having to write any code, is what it is. It's a drag and drop tool, and it's a visualization tool is what it is about, guys. Okay, we'll try to talk a little bit in the coming up days, but everybody okay with the slide? Quick yes, please. Okay. Okay, let's take a short 5-minute break, guys. 3:16, 3:21. Please take a short 5-minute break and come back. Okay, yes, are you back? Can you give me a quick yes, please, if you're back? Okay, thank you, guys. Okay, so back to Hadoop, Spark, and Databricks, guys. Let's see. Hadoop creates datasets with a variety of data. In other words, what we really do in the world of Hadoop, guys, we get a variety of data that could be structured, that could be semi-structured, that could be unstructured data. That is what is the variety of the data. What are we doing is we create means we are loading the data. That is where our commands of Hadoop, Hadoop FS, data, put, get, and all those things that we have discussed earlier. That is the process of loading the data. Creating data sets means you're loading the data. Then what do? We try to process and analyze. That's where the MapReduce comes into the picture. The objective of these techniques is to find the insights or the intelligence in the data. We have discussed earlier, we can run them on cheap servers. The cheap servers are called commodity servers. The problem with the commodity servers is they can fail anytime. So what do? That's why we replicate the data. If the data on one server is lost, we can get the data, the same data from another server. And since we are using commodity servers, the cost is reducing. We can add more storage, which means we can add more disks. There can be hundreds and thousands of nodes. Nodes means servers in the world of Hadoop. But all those 1,000 of them or thousands of them, they will act like they are one computer. That is what is the magic of Hadoop, if you recall. Okay, and what is that? That is Hadoop distributed file system. It makes a group of computers act like one. Computer is what it is. That is the data storage. That's where HDFS is acting like a data storage. MapReduce, we can write MapReduce programs. Parallelization is built into it. And that is massive, which means you can have hundreds and thousands or tens of thousands of nodes or servers, and we don't change the code. We can write a Java, we can write a MapReduce program in Java, we can write it in Python, but a more shortcut is Hive and Pig. And then we have Spark. Okay, Hive gives us SQL. Like in Hive, we give SQL like input. Internally, it is getting converted into MapReduce programs. And what is that? That is nothing but Spark also. In Spark also, we will give SQL like input, and it will internally get converted into Java, internally it will convert it into Java MapReduce somewhere deep inside, and it will execute it, guys. Okay, and that's what we will see and discuss in coming up slides. So we have discussed about Hive. A Spark, okay, that's what we'll try to understand. How about processing in memory? So what is special about Spark is in-memory computing. MapReduce generally is using hard drives. Hard drive is the slowest component of the computer or the server. But you come to Spark, Spark is the fastest component of the computer. Or it is the fastest, one of the fastest components. Spark, what can you do? It can be really fast. It saves all its data in the memory, which means in the RAM. As a result of that, it can achieve up to 100 times faster than a normal MapReduce. That is why everybody is trying to adopt Spark. If you make sufficient memory available, which means when you have hundreds and thousands of computers, all their RAM will be used in loading the data and at the time of processing the data. All that is taken care of by Spark. Okay, again, in Spark also, we can run the programs in Java, in Python, in R, in SQL and Scala programming. We'll try to touch the basics if the time permits in coming up days. Scala is also like Python, fortunately. So with a little bit of Python, we should be able to pick up Scala also easily, guys, okay? Run data analytics, data processing, and machine learning workloads. Again, we are going to use Spark to do similar things that we have done in Hive and Pig. We analyze the data, we process the data, we can also run machine learning algorithms. Most of the times when it is time to run machine learning algorithms, everybody will go back to Python and will try to run them in Python. So Spark provides PySpark. we can run the machine learning algorithms in PySpark in the world of Spark, is what it is, guys. Okay. In the world of Hive and Pig, generally, we don't use them for machine learning. But in the world of Spark, we can use Python and run it on top of the Spark, which is referred as PySpark. That's what we will get a touch of it here. It has become very popular and is offered as a separate service in most cloud platforms. So again, installing Spark is a big deal. And generally, this is separated from the data scientists and the people who are analyzing the data. So what they're doing is they're offering it as a separate service in the cloud so that people don't have to worry about installing Spark and things like that. And they're giving all the cloud capabilities. You pay for what you use, you auto scale, all those things are automatically provided. That is what Azure will take care of. Everybody with me so far, guys? Quick yes, please. Quick yes, please. Are you with me, guys? Gentlemen, ladies, are you with me? Okay. So that is where the Databricks comes into the picture. Databricks is nothing but Spark on the web. It is called as a web-based platform for working with Spark. We can write Python programs, we can write Scala programs, we can write R programs, we can write Java programs and other kinds of programs. The most popular one is PySpark, where people are writing everything in Python on top of Spark on the web. And that's what we'll try to understand today and tomorrow. So it's like a centralized platform for machine learning. So earlier we have used Jupyter notebooks. Databricks provides these notebooks on the cloud. We have, so in other words, we've been running the notebooks on the cloud only indirectly, guys. Okay. But here, Databricks is going to allow us to run on their platform, which is on Azure Cloud. And why do we run them? For machine learning, for streaming analytics, in other words, that is data analytics, for doing business intelligence, which is again prescriptive analytics, or in other words, the descriptive analytics and the diagnostic analytics. These are the things that are generally performed using PySpark. They're founded by the creators of Apache Spark. In other words, again, it has its own creators, founders. Automated cluster management. In other words, Spark will indirectly take care of the cluster management. And if you recall, what is a cluster? Cluster is a group of racks. What is a rack? A rack is a group of servers. So based on the data, Spark will automatically take care of how many servers are needed, how many servers are not needed. All that is being handled. Internally, the architecture of Spark is again similar to Hadoop, which is like a master worker architecture. Everybody with me, guys? Quick yes, please. And all that is taken by Spark from a computation standpoint. Hadoop is also taking it from a storage standpoint and a computation standpoint. Hadoop is taking care of it. But at the time of computation or processing, Hadoop is using the hard drive. Spark uses RAM, which is in memory. As a result of that, the analysis, the analytics is happening 100 times. We can achieve up to 100 times faster speed, is what is the advantage of Spark. Everybody okay with this slide? Quick yes, please. Okay. Let's see what is Spark. Okay. So this is kind of a form of a data or a format of data. It is called columnar storage format. Apache Parquet. It's called a columnar storage format. And it gives us the advantage of that is we will store the data in the form of columns, and one of the advantages is high compression. We get a lot of storage is saved, is what it is. It is efficient for big data, especially in the world of big data. What they do is there are different formats of data. Parquet is one of the popular format where it will take your textual data and store it in the form of binary content. That is very, very compressed. And so you may have 1 GB of textual data. If you save it in Parquet, that might become something like half GB or maybe 1/3 GB. It's like a zip file, more of a binary format and things like that. For the sake of simplicity, you can think of it. That is why it is very efficient. It is introduced again, it is coming out from the Hadoop world. It is supported by most big data platforms. So again, almost every big data platform is supported. There are other formats also which are supported. So Azure Data Factory supports Parquet for both read and write, source and sync. Source and sync. Source is the tap. Imagine water flowing from tap into a bucket. The sink is the bucket. The source is the tap. Okay. So in other words, we can read the file and also write the files in Parquet. The reading and writing is happening in Parquet at a technical level. But when you read the data, you will get back your original data, your original text data. When it writes and saves the data to store, to reduce the storage space, it will save it in Parquet format. That's what is slightly deep, guys, okay? Azure Data Lake Storage or Blob Storage stored data in Parquet format. So why? Parquet is again highly compressed. It kind of compresses its data, and that is why we can store more amounts of data. Azure Synapse Analytics can be used to store tabular representation of data in Parquet. So Azure Synapse also is going to store the data in Parquet format, which is nothing but a binary format. It's like a zip format in the Hadoop world. As a result of that, we get a lot of storage space frees up is what it is. Everybody catching that, guys? Quick yes, please. These are some terms. I don't need you to by heart these things, but before going to a certification exam, or by the time you go to a certification exam, we should be able to read this 2 or 3 times. Just be familiar with them. And again, the questions will be translated from here. Some of these points are going to be translated into questions, multiple choice, true or false, and things like that. That is what you would be getting this, okay? Quick yes, please. Everybody okay with the slide? Okay. Let's move to the next one. Okay, Hadoop and Spark in Azure. So Hadoop is installed in Azure. On top of it, Spark is installed. We get the best of both the worlds. And what's happening? That's happening on cloud. Azure HD Insight. It is a managed Hadoop, means they are already installing Hadoop and giving it to us on the cloud. That is referred as HD Insight. That's a Hadoop distribution. Okay, process big data. So on that one, again, what do? You store big data, you process the big data on Hadoop. We can also use Spark on that. We can write our own Spark programs. Azure Databricks. Again, we have seen it is nothing but web-based data platform. It is also a platform which is allowing us to run Spark programs. We have they have a premium Spark offering because a lot of people are buying it. It becomes easy for them to work with big data very quickly. Focused only on running Apache Spark workloads. Okay, so Azure Databricks only runs this Spark, is specifically meant for Spark is what it means. And it can consume Azure SQL consume data, which means what it means is there is a database. So here is a database. This database can be SQL database. It can be Cosmos NoSQL database or other kinds of sources. They get the data into the world of Hadoop, into the world of Spark. And then what do? They process the data. They analyze the data. That is generally the process. So other Spark integrations, Azure Synapse Analytics, they can run Spark jobs. Spark jobs are nothing but Spark programs. Apache Spark for Azure. We are running the Spark programs on the cloud, so we're getting all the benefits of cloud computing. On top of it, we're getting the benefits of Spark, the cluster management and other things. Azure Data Factory runs pipelines. This is nothing but a group of steps which are being run one after one, involving big data, involving Hadoop and Spark programs is what it refers to, guys. Okay, everybody okay with this slide, guys? Quick yes, please. Just a little touch of Hadoop and Spark from different perspectives is what we are saying here. Okay, so come back here. Okay, is anybody ready? Have any one of you connected to Azure Lab, guys? Let's see. One more time. Any volunteers there? Pravalika. Okay. I'll make you the co-host. Please try to share the screen, Pravalika. So participants. Let's see, where is Pravalika? Like the co-host. You can unmute yourself and okay, good. Give me one moment here. Okay. So the first step, in the search window, type in Databricks. You should be seeing something like, select the Azure Databricks. Then click on Create Databricks Service. Okay, then create, G1, okay. G1. Okay, give a workspace name, something like Databricks workspace. And I'm going to be doing a little bit of multitasking here. Give me one moment. Making some changes for you. Okay. Databricks workspace. Okay, the name is okay. Then I think you can leave that as standard. East US 1. Okay, we'll leave that. Then go to next. Deploy Azure Workspace. No. Deploy Azure Workspace in your own version. No. Yeah. Click on next, which is advanced. No changes in advanced. You can directly go to review and create. Okay. Create it, please. Yeah. Then once you give it a movement, after it, you should see a launch workspace. Still in progress, okay. Still in progress, okay. Okay, let me know once it is done. Multitasking.
Okay, sir.
Thank you.
It's done now.
Okay. So let's say click on go to resource. Launch workspace. Is that your TM account?
Yes, ma'am.
Okay. Okay, click on new notebook. That should be your Jupyter notebook. Just say my first notebook. Have you clicked on the new notebook?
Yes, ma'am. Created.
Okay. No, what are you doing? You're closing it again.
I already created, Naveen. After
Oh,
that,
sorry.
it's.
Okay,
like
you
this.
just click on done then. Okay, just enter 1 + 1. Shift enter.
It's not moving to the next one, sir.
Okay, just say run cell. Shift enter is not working.
No.
Shift enter is not working.
No, Naveen.
I'm not able to hear you, Pravalika.
No, Naveen. It's not working. No, Naveen.
Anybody else tried running the Databricks, guys? Anyone of you? Anybody else logged in along with Pravalika? Refresh this one for a moment, Pravalika. Refresh, run it. Are you sure Shift Enter is not working?
Yes, Naveen.
Try creating a new cell.
Okay.
There's a plus sign coming up, right? మధ్యలో ప్లస్ సైన్ వస్తుంది చూడు. Try the other ones. Run all above or run all. Run.
Naveen, here the result is no, it's gone.
Navya, is it running for you? Strange. Hold on one moment. Okay, sending the screenshot to them. Strange. Let's see what else I have here. Back to okay. Let's see. Go back to the previous tab, Databricks Workspace. And no. Come back here, My First Notebook. And click on that left side icons, that menu icons. Let's say create workspace, repos, reasons. Click on the data science and engineering on the top. Yeah. So select data science and engineering, select that one. And scroll down here a little bit. Sample workbooks. Again, click on the left-hand side. Select the drop-down again. Select machine learning. Machine learning and deep learning, right? Create a notebook for query. AutoML, different solutions, learn from notebooks. Okay, click on the reference solutions on the right-hand side. Scroll down a little bit. Reference solution recommended insight. Getting started with machine learning, end-to-end examples of building. Scroll down. Click on the 10-minute tutorial. Scroll down, please. Scikit-learn, end-to-end example. That is scikit-learn. Okay, scroll down. Machine learning. Okay, scroll up. Click on machine learning quick start. Click on that example notebook on the right-hand side. And let's say, click on get notebook. Okay, scroll down, please. Scroll down. Keep going down. Go down. Keep down. Once you show me, keep going down. Okay. This is a slightly tough one, but scroll all the way up, please. Now, what we'll do is we'll see, scroll a little bit down into the next cell. Execute that cell. Try to execute that cell. Right click that. Is there any option? Or I think what you do is on the right hand side on the top, notice there is import notebook. Click on that. Just say, you need to do it right now. Okay. Click on copy. Done. And paste it there in your URL. Have you pasted it? Prolika? Not on mute, aren't you?
Same thing, Navin, after I pasted that.
You're not able to execute it, right?
Yes, Navin.
Okay. A few small things I wanted to show you, but let's see. Massively parallel processing, batch pipelines. Let's take up this one. $285. Okay, so in that case, what we'll do, let me share my screen again. We'll see if the guys will come back. I'm going to share my screen, Prolika.
Okay.
Thank you. Okay, let's dig a little bit deep into some of the other definitions, guys, okay? Massively parallel processing, we have discussed about this in MapReduce, if you guys may recall. Okay, stop this one. Say, share this one, share it. And now bring this up.
Hello, Navin.
Yeah,
It's running, Navin.
and let's see.
Hello.
Running for you?
Yeah, Navin, it's running for me.
Wait 1 second. May I stop my share here? Who's that, buddy?
Satish Pagdala, Navin.
Oh, okay. I'll make you the co-host. Click on yes. And try to share your screen, buddy.
Okay, now.
Okay. Okay, good. So just enter print Mera Bharat or something like that. Okay, why are you getting the error?
It's missing.
Okay. So what's your name? Pravalika, I wonder why you're not getting and why Satish is getting. Keep trying and let me know if it works for you in the meantime, okay?
I need to create a cluster, it seems.
Cluster Naveen, yes, yes. Yes,
Uh,
Naveen, I have
that's the difference.
created a cluster.
You did not create a cluster. Okay. Strange. Okay. Okay. So let's see. Let's click on this one and back here. Down. So we created a notebook, Azure Database Workspace. There we are, and we launched it. Created a new new notebook. I directly created a notebook rather than a cluster. That's the problem. Oh boy. Okay. See what is the problem. Could have created a temporary cluster also, but anyway, I'll take that. So when you go back to your cluster, here. I think you need to change some settings. Let's see, click on the cluster. And let's say, one moment. Wait. You chose 12 cores and LTS, Spark 3.1.2, Scala 1.2. Okay, you've already chosen that one. Okay, that's okay. Anyhow, that will be removed. So we don't need to worry. I wanted to scale down the cluster before we do that. Okay, database cluster, then you created a notebook. Okay, now what we'll do is, we need to go to the sample data sets here. Go to your google.com and just type in Azure Open Datasets. Azure Open Datasets. Microsoft Open. Okay, click on the first link. Pricing, no. Scroll back. Big datasets. Create on public. Azure Open Dataset Catalog, or just type in Azure Open Dataset Catalog. Oops, not that one. You need to go to Azure. Don't click it. It should be something like look for docs.microsoft.com if there is any link. No, scroll down. Here we go. There you go. The fourth one.
This one now. Open data.
Okay. Let's see. Scroll down and look for US labor force. I think if you click on that US labor. And if you, so here is the data. Scroll down, keep scrolling down. This is a preview of the data. The above one is, I think, the metadata. Scroll down. Keep scrolling down. Now click on the PySpark. On the right hand side, there is PySpark. By side, in the middle, there is oops, in the middle.
Yeah, no.
Yeah. Now what you do, Copy the first one, click on copy. Okay, now go to your the notebook that we just created in a data breaks. Okay, in the new cell, paste it in the new cell. And run it. Command took 0.02. Okay, so it run. Okay, next go back to that same window, the labor window. Next, copy the next set of it. Paste it and run it. Okay. And like that, you keep running the next 3 or 4 steps in that one, the next 2. Give me one
Okay,
moment here.
Done, Naveen.
So now go to the first cell that you ran here. Okay, so the blob account name, this is an open source. This is like an open data set provided by Azure. And these are some of the settings they have given us. LFS is local file system. We don't need to understand this part of it. This is generally where we give our C drive, our HDFS address and things like that. That is what this cell is. But again, we can, I mean, in the later days, you can, these things will become pretty straightforward. The next one, again, scroll down. The next cell is WSABS path. This is where actually the path is given. When we actually get into the basics of Sparks, we need to, that is what this line is doing. Here, we are not going to learn much about the syntax of Spark, but we'll touch a little bit of Scala in the coming. So for now, we'll not touch the Spark conf, or we don't need to understand it. But go to the next cell. So notice here, what we are doing is we are getting the WASBS path, or in other words, Spark is reading the data from online, from the internet. And what it is doing is it is converting it to a data frame. DF is a data frame. It is converting a Parquet file into a data frame. And then it is doing a create or replace temp view. Again, this is also a little bit in-depth into Spark. You don't need to understand all these things. But I will explain you once why. You just bear with me a little bit, and I'll explain you why I'm explaining these things. So scroll up, please. When you say create or replace temp view, what happens is after you create a view, we can issue SQL commands. The same SQL commands that we have been looking at and running in database, now we can start running on this data frame, just like hide. And we can analyze the data, we can process the data. That is what is the objective. Now go to the next line. Below set. Now notice here, say create or replace temp view. Notice spark.sql. Select star. That is nothing but that is SQL commands. We are giving the SQL commands, and we are able to execute it on a data frame. What is that? That is what Spark is handling. Now, what is the catch here? Our data set can be as big as very, very huge. HDFS, it could be a very, very huge file and things like that. We are giving SQL commands. The only difference is we are running on Spark, not on Hive. Everybody catching that, guys? Quick yes, please. Gentlemen, ladies, are you catching that? So ideally, what will happen in a real world is, pardon me, in real world, we will be writing different kinds of SQL commands. We will be getting our data. Once we get our data, now scroll down a little bit, Satish. Now, if you notice, there are 4 icons in the below. In the down arrow, in that arrow on the right hand side. Right. No. The one towards the right, man. ఆ పక్కన పెట్టు రైట్ హ్యాండ్ సైడ్ ఇంకోటి ఉంది కదా క్లిక్ చే దాన్ని తీసే now put your, don't click it, but put your cursor on the down arrow. Notice it says download CSV. If we click on this, we can download this entire file as a CSV. Generally what we do is big data files, we don't download them straight away. You write a filter. Imagine there's a multi-terabyte file. You write a filter, you apply a filter. It is generally reduces the data to maybe 1 GB, 10 GB. Those are the files which we catching the point, guys? Put your arrow on the middle one, the drop down. Give me one moment here. So now click on that one, drop down. Now let's say select a bar chart. Click on bar. These are the different kinds of visualizations that we can do. So now what is happening is there is something called DLSA code, which is on the y-axis. It looks like there are two of the columns on the x-axis. This is the title of the x-axis, y-axis, and things like that is given. Now what we can do is we can select the columns here. How we can select the columns is click on plot options. So this is like a built-in visualization. So here what we'll do is, let's say, let me see. We have a group stacked and 100% stacked. We'll probably select year on the top and value in the below. Okay. So what you do is remove the seasonal. There's a X right by the side of seasonal. Click on that. Remove it. Remove that. Remove that. Now on the left hand side, there's in this box, look for year. There's a column called year. You drag and drop it into the keys. I think you have to go on the top. You drag and drop it on, scroll up. Go on. It's the first one, I think.
Yeah, done.
Scroll it up. Go up. But
I have pasted down.
You drag and drop. Now,
Yeah, Naveen.
Now remove that. By the values, remove the DSA code. Remove the DSA code and look for drag and drop the value on the left hand side into values.
Yeah, done.
Okay, so
Naveen.
notice now the chart has come up in 1972. How many values have been, how many were probably employed, unemployed, whatever that value is. 73, 74, the unemployment probably went down. Now there is something called display type below, drop down. Click on the drop down and let's say select maybe line chart. Okay, line chart. Let's select maybe bar chart. Click on, select another one. No, sorry, pie chart. Select pie chart. Okay, now click on apply. Notice when you click on apply, that visualization is coming here. Ideally, what the data scientists will do is they will try out various permutations and combinations of the data visualization. They will play around with lots and lots of visualizations, tens and tens of visualizations. They will try to understand the meaning in these pie chart, line chart, bar chart, and they will try to apply them. This notebook itself will become a huge source. So here, 40% of them are from 73, whatever that value is. Maybe there was 40% unemployment in 73. 74, it is, how much is it? Green, 21%. So the unemployment is reduced. This is a donut chart, actually. We can take other things and so on. So what is that? That is the insight that we are getting. What do data scientists do? This is what they do. They will create tens and tens of such charts. This is the first, this is one of the steps of processing where they're visualizing the data. And then what do they do? After this step, they will try to apply machine learning algorithms. Now, machine learning algorithms is out of the scope of our course, so we'll not go into them. But imagine you are spending hours, days, and weeks creating these visualizations, spending on algorithm. What is that? That is data analytics. Everybody catching the point, guys? Quick yes, please. And imagine every visualization, whichever looks meaningful. What do? Ideally, you will learn the techniques. Before you become a data scientist, we generally learn the techniques of charts. And then, which is giving us this one, that becomes a dashboard. It becomes something like a dashboard, is what it is. Catching the point, guys? Everybody with me? Quick yes, please. And that's what data scientists do. They work with colors, data, and things like that, guys. Okay, because they spend a lot of time processing, analyzing, and visualizing the story of the notebook. And let's see what else we have. So like that, what happens, guys? Okay, click on go back to your cluster, Satish. Okay, go to cluster and let's have a configuration on Azure. Clusters. On the left hand side, on the top, there is something called cluster.
This one, Navin?
No. On the top left hand side, there is clusters.
Top left hand side.
You take this clusters. You don't have strong eyes. There you go. You don't play sports, do you?
I play, Navin.
You play any sports, Satish? Click on that.
Yeah, na. Create a cluster, Navin.
You don't play, huh?
I play, Navin.
Which one you play?
Coco, Kabaddi, and Coco, Kabaddi, Throwball, and Shuttle.
Then your eyes should be strong.
I show you, Navin, that I have placed the cursor on cluster, but I didn't get any response from you. So I was searching. That was not the thing I thought, and I was searching for another cluster.
No problem, buddy. I'm just kidding.
Okay.
So now let's see on 3. I just there should be an option here to delete it. Just for the sake of discipline, we'll delete it because these are expensive stuff.
Okay, Navin. Here is the option.
Delete it. Yeah, delete it. It's like the UI changed a little bit.
The cluster will be removed. Okay, Navin. It has been removed.
Okay. So that is how the data scientists generally create the cluster. You need to have an idea how to create a cluster, how to create a notebook, what is generally done in a notebook and things like that. Tomorrow, if you sit with a colleague who's a data scientist or maybe a data analyst, they will be showing you these steps and you need to be familiar. They will not expect you to be an expert or anything, but if you're able to understand, if you're able to work with them, they will be comfortable. That's a good level to be in from a practical standpoint. Everybody with me, guys? Quick yes, please. From a theoretical standpoint, we'll again get back to theory and the questions and things like that. We'll target them for the certification exam, guys. This is a touch of the Databricks notebook. Okay. So now let me come back here. Thank you, Satish. Good job, buddy.
Thank you, Navin.
You can stop sharing the screen. So I'm going to share the screen. Just updating the support folks, guys. And come back here and let me bring this up. Here we go. Sharing the screen and it's okay. So massively parallel processing, again, remember we have discussed about parallel processing. In the world of big data, it's automatically built into the MapReduce and things like that. And generally referred as MPP. So the data is split and it is being processed across multiple servers. Typically separate storage and compute, which means the data is there at one location, the compute is moving to the storage where the data is stored. Then we have discussed about the master and the worker execution. Execution workers can be hundreds and thousands. All that is being taken care of. What is that? That's a data lake. Data lake is nothing but where we have structured data and we're trying to perform the data warehousing stuff on that. Scale compute on demand is where, based on the number of servers and things like that, the workers, the data is getting split and distributed automatically. And then the computation also happens automatically. So not only storage is getting distributed, but the computation is also getting distributed and it is running at that time. And all these things, we don't need to again worry about the hardware and things like that. We can directly get started and start working on that. So Spark, Azure Synapse Analytics. Okay, so these are the tools. Let's say, come here. Okay. Next, let's go a little bit deep into some technical stuff. So here is batch pipelines. So generally we take the data and we try to store the data. Then we either perform a batch processing or we perform a streaming. Then we try to analyze the data. Then we come up with reports, visualizations, and things like that. That is the process, guys. Okay. So batch processing is again nothing but bank statement is a mantra. Buffering and processing data. Buffering means you take 100,000. Let's say Citibank has maybe what is the popular SBI has 100,000 customers. It is taking 100,000 customers every month end, that is buffering, and then processing their data, creating a bank statement, creating the PDFs and things like that. What is that? That is batch processing. Define condition, how often to run. So that is run, that could be 6 hours, 6 days, or 6 weeks. How many records? Based on your number of customers you run that, that is batch processing. So generally when we talk about Hadoop, it's big data. Hadoop was associated with batch processing. Not for small data processing, Hadoop was not used. Advantages process huge volumes of data. During off-peak hours, okay, we can run that during off-peak based on the requirements. And typically it takes longer to run. In other words, there is delay. Why? Because we're working with huge amounts of data. There is the delay is acceptable in a business world. You don't need that to be run in just a second or like a database operation or things like that. Example, read from storage, process and write to relational database or NoSQL. Okay, this is another example where we are saying reading the data. We're getting the data from data lake and doing some changes to it, which is processing it and saving it to a database. That could be something like a scoop where we are saving it from Hadoop to NoSQL or from Hadoop to some other database or data warehouse. More importantly, batch processing. Bank statement is the first mantra. The second mantra is there is a delay. That is okay. And what do? We buffer. We take large amounts of data. That is what we need to keep in mind. Everybody with me? Quick yes, please. Gentlemen, ladies, quick yes, please. Okay. Streaming is small data processing or taking small amounts of data. So there it is. Let's say, oops, come back here. Okay. So you take the data, you can save it into, the data is coming from an event hub, IoT hub, or anywhere, in different places it comes in. It comes in small amounts of data, just like stock data. Stock data changes every few seconds, weather data changes every few seconds to minutes. So what is it? That is streaming data, something which is changing and coming in continuously streaming. And again, what do? You take the data, you can use Spark, Hive, pick whatever you want, and you try to analyze the data. And then you generate the report. The report can be in the form of a notebook or in any other form also. Streaming is real-time data. At that point of time, we are taking the data and we are analyzing the data. That's why it's called, that is the reason it is called real-time. Processing data as it arrives. In other words, again, stock data arrives in seconds. It can also arrive in milliseconds. And the sensors, the IoT world and things like that, smart cities and all those things, they have these IoT devices and sensors installed all over. And that generally comes in the matter of seconds and milliseconds. A lot of volume of data gets accumulated. That is what is big data. Stock market data, we talked about it. User action metrics from different websites. So if you take something like Amazon, a lot of people are coming to Amazon and they are looking at different things and so on. So based on their clicks and things like that, we can generate different kinds of metrics. We can try to understand, we can perform what is called clickstream analytics and things like that. Guys. Again, that is part of the data analytics. But here we need to understand streaming processing means real-time processing. Real-time at that point of time. What is the data? What data looks like? It is generally small amounts of data, not big amounts of data. So kind of the opposite to big data or batch processing. Quick yes, please. Everybody okay with this slide? Okay. So let's say I come back here, take a look at this. Stream versus batch. Time period batch is happening in batches. All the data from few hours to few days to few months. It depends on your requirements or on the requirements of the company, whether they want to process hourly data, days data, or monthly data. You take that. Process most recent data. Streaming is you take the most current data. You want to predict the last, based on the last 30 seconds of the stock prices, you want to predict what the new stock prices is going to be. Is it going to be increasing? Is it going to be decreasing? That's a big scenario. Big use case in a stock market world. Is the price going to increase or decrease? They write their custom programs. These are called algorithmic trading strategies. A lot of research goes into them and people are paid a lot of money to do that kind of algorithms and things like that. That is why the data analytics is so powerful. They can really do some good job in predicting the stock market and make a lot of money, guys. Okay. Then the data size in batch, generally the data set is large. In streaming, it is generally a few records of data. They're also referred as micro batches, a little bit of terminology. Here and there, they will use some special these terms and your questions and things like that, guys. Okay. Latency is high, which means it can take few minutes to hours to days. That's acceptable in a business world. There's no problem. But in a streaming world, most of the times you cannot accept it. You need some operation, some transaction to happen. If you swipe your credit card, you cannot wait for hours. If it takes a few minutes only, everybody will stop using it. It needs to happen in a few seconds to a few milliseconds. And that is the nature of it. That is nothing wrong. Or more precisely, that is the nature of it, guys. Okay. So use case used for performing complex storage analysis. So again, big data storage, big data and analytics is what is batch processing about. And this is used for storing individual records. Based on that record, you want to predict something, you want to do some other calculations and things like that. That is when the streaming is used. Everybody okay with this slide, guys? Quick yes, please. Slightly deep one. We are getting into some heavyweight data analytics terminologies here, but you guys need to be familiar with these things for the certification, guys. One more time, quick yes, please. Okay. Let's see, Satish, are you still there, buddy? Can you unmute yourself? Are you able to unmute yourself? Oh, what is happening? Pravalika, are you there? Can you unmute yourself, please?
Yes, Navin.
Please read the question and decide what is going to be the correct answers.
What are the two uses of data visualization? Each correct answer presents upfront. Incomplete machine learning to predict future values. Consistently implement business logic across reports. Communicate the significance of data. Represents trends and patterns over time. Data visualization. A and or D, Navin? Navin? Navin?
Sorry about that, Pravalika. What do you think is your answer?
C and D.
Communicate the significance of the data. What do you think is the significance? What does it mean?
What the data describes.
Very good. And represent the trends and patterns over time means? What does trend and pattern mean?
Features.
Trends, patterns is again nothing but the pattern, something useful, something helpful, something meaningful. Okay?
Okay.
Okay, read the next question.
A visualization that shows a university's current student enrollment versus the maximum capacity is an example of cognitive analytics, descriptive analytics, predictive analytics, and perspective analytics.
Tough question. Feel free to help her out, guys.
Predictive analytics.
Why do you think so?
By seeing the current data, we are predicting like how many students can be enrolled or what's the maximum capacity.
So more precisely, this will be descriptive analytics. What's happening is it shows university's current student enrollment. How many students already enrolled means this is something which already happened. Descriptive analytics is about understanding what or something already happened. The mantra of descriptive analytics is looking in the past or looking in the history. Here, they are not asking you to predict student enrollment or capacity. If they're asking you to make a prediction that is future, that did not happen, that will be predictive analytics. A slightly more advanced thing is a prescriptive analytics. Cognitive analytics means it is where we are converting text to speech, speech to text, video analytics and things like that, where the bots and things like that are coming into the picture. That's what is cognitive analytics. So I think the answer is descriptive. Let us see. There it is. For you, short and sweet, you need to constantly keep in mind the mantra of descriptive analytics is what already happened. You're trying to analyze and understand something already happened. What happened? Something happened. What is that? That is what is descriptive. Okay, Pravalika?
Okay, now.
Okay, so let's see. Here's another tough one. Read, please.
Your company recently reported sales from the third quarter. You have the chart shows in the following exhibit.
Okay, now if you take a look at this blue line here, based on this blue line, you have sales on the y-axis, quarter on the x-axis. What do you think the blue line is explaining? What sense can you make out of this one? It's
As
a tough question.
the time progress, as the time progress, the sales might have reduced to this point, like the center, and then started to increase.
Very good. In other words, the sales have started decreasing, and after a certain point, the sales have started increasing.
Okay.
Are you understanding, Pravalika?
Yes, ma'am.
What is the green line showing is that is a prediction. This is a rough sketch. So this is how your company report is looking like from the third quarter is what they are saying. Now, which type of analytics is shown for the fourth quarter? Okay. In other words, if you look at the green lines, what kind of analytics does that fall in? Here is the green.
Perspective.
Why do you think that is perspective?
Predictive, it might be. Perspective is like what actions do we take, right? So it might be predictive.
And why do you think it is predictive?
We have drawn three lines like how it might be during the fourth quarter, so it might be predictive.
Very good. The green lines are indicating what is the prediction. So that should be predictive analytics, as simple as that. Predictive means what is going to happen is what is predictive. So that will be predictive analytics, okay?
Okay. Now.
Do you remember what is the mantra of diagnostic analytics?
Why it is happening.
Good. These are the mantras I want you to keep in mind. Descriptive is what, diagnostic is why, predictive is future, prescriptive is the action for the future. That's a slightly deep one, but let's see. Proceed, Pravalika.
To complete the sentence, select the appropriate option in the answer area. A relational database is appropriate for a scenario that involves a high volume of changes to relational between entities, geographical distributed rights, transactional rights, rights that have varying data structures. Changes to relational between entities.
Do you know what that means?
Sir?
Do you know what that means?
Changes between the connectivity of tables.
Good one. Okay. So in other words, I think what that means is changes to relation. There's a lot of updates happening. Change means modify, modify means update. So there are a lot of modifies happening. If you have a lot of modifies happening, will you use a relational database is the question. And let's say a relational database. They're saying a relational database. Is it appropriate when you make a lot of changes? Is the A part of it? And B is geographical distributed rights. What do you think is the meaning of that? That's a tough question. Feel free to help Pravalika guys if you have any hints and things like that.
Like changes done all over at a time.
Change is done all over. Okay. So geographical distributed rights is your, whatever you're writing means you're inserting, you're updating, or more precisely, you're inserting the rows, and these rows are getting inserted across multiple geographies, multiple regions around the world. That's what that means. Then transactional rights. What do you think is transactional rights, Pravalika?
Transactional rights. Able to change the transaction.
Right means, for now, think of it as an insert.
Okay.
So we're doing a lot of inserts. What is a transaction?
Like table rows and columns.
Good. Records, rows, records. That can be a single record in certain scenarios. That could be a group of records. If you're doing a lot of inserts, do you think you need a database? Simple answer, that is what it is required for. To insert the data, you need a database. To modify the data, you need a database. Okay. Then come to the fourth option, rights that are having varying data structures. What do you think is the meaning of that? Tough question. So this one question, it has 4 or 5 or maybe 5 or 6 questions inside this. They translated that into one certification question, guys. They're increasing the complexity here in a way. Give a thought, Pravalika.
Okay. Schema changing.
Good answer, good answer. That's objects and things like that is what is. I think the answer is A and C here. Let me see if I have recorded. Okay. They're saying it's transactional rights. It is mostly, we use a relational database when we have a lot of inserts going, is what they are indicating here, guys. Okay. Let's see. Proceed, please.
In batch processing, drop down. Data is always inserted in one row at a time. Data is processed in real time. Latency is expected. Processing can only execute serially. Processing can execute on latency is expected.
Why?
Because if it is real-time processing, there won't be that much latency, like delay. But it is batch processing. We are processing we are sending out the result only batch wise, not continuously. So the latency can be expected.
Excellent. Okay, if you really understood that, that's a very good answer. But let's see, data is always inserted in one row at a time means, what do you think is the meaning of that?
Only once the data is able to be inserted, like at a time. Not rewriting it again.
Processing can only execute serially means?
Like order wise.
Simple as that. Okay, so we need to understand. So let's say, I think the latency is expected is the right answer. In batch processing, because we deal with a lot of data, batch data, that's what is the definition. And that's what we've been discussing repeatedly. Okay, Pravalika?
Okay. Match the types of workloads to the appropriate scenarios. Okay. Analyzing web traffic from the past year. Classifying images that were uploaded last month. Tracking how many people are currently using. Options are batch and streaming. A and B are batch and C is streaming.
A and B are batch. Explain why. So among these 3 options, which is your thing?
I could only see 2 options. Are those only?
2 options. Are you saying 2?
Yeah, 246 and 136.
Oops. 1 second. How come you're not seeing the third one? Okay, how about now?
Oh, yes, I can see. Sir, is it 136?
So you take now. Okay, now explain me why. Hello, are you there?
Yes, sir. Yes, no. Traffic capacity.
You already answered it, Pravalika.
Says, okay. From the past year, like we are collecting
Good.
only for a period of time, so it is batch. It is not continuous, so it is batch.
Good. Next.
Classifying images that were uploaded last month is also batch, since we are not collecting the currently tracking. So
Good.
C is streaming, since we are collecting the data which is currently being used. So
Excellent.
C is streaming.
So I think the right answer is 136. Let's see. Let's give it. Okay, that's 136. Okay. Okay.
You have an e-commerce application that reads and writes data to an Azure SQL database. Which type of processing does the application use? Stream processing, batch processing, online analytical processing, online transaction processing. So is it online transaction processing?
Why? Why are you calling it as transaction processing?
So
Because it is a database, SQL database, and it is transaction processing means it is database. Analytical processing means it's a data warehouse. Reads and writes. E-commerce application, you're reading and writing means you're inserting the data, you're reading the data. That is transactions. In e-commerce, lots of transactions happen. Whenever we are talking in terms of transaction, that is transaction processing. Whenever we are talking in terms of reporting, that is where analytical processing is going to come into picture. Then we already talked about batch processing and stream processing, but here it is transaction processing. A database is a transaction processing software. Understand, Pravalika?
okay.
So that is transaction processing. Let's see where we are. Okay, let's take one more question. Okay.
What are the 3 characteristics of an online transaction processing workload?
Are you
Schema
able to
on
see the 4 options?
Navin.
Okay.
Schema on write, light writes and heavy reads, heavy writes and moderate reads, normalized data, schema on read, denormalized data.
This is a tough one. There are 10 concepts they put into one certification question, guys. What is an online transaction processing software?
Reading and writing data into database, just
It's
as
a
you said.
database. Short answer, it's a database. That's what we just talked about, right?
Yes.
Now here's a tough question. What do you think schema on write means? This is a very tough one. What do you think is schema?
Metadata.
Schema means your column names, metadata, data types, relationships, constraints, and things like that is schema. Now, in a database, do we need schema?
Yes.
Why?
Define schema for a database to insert or to perform anything.
Very good. In other words, that is the nature of it. Before we insert data into a table, we are defining the schema. You're saying, hey, here are the column names, data types. And so at the time, schema on write means at the time of writing, schema is required. You need all the things to be. So that is one thing. Now, light writes and heavy reads. Can you tell me can you guess what it means, Pravalika?
Less write operations and more read operations.
Very good. Now, do you think they will happen in a database world?
Yes.
Why?
We insert data in it. So write and read operations happen.
Light writes. Do you think less number of inserts are happening or less number of reads are happening? Do you insert less records or lot of records?
It can be more or less.
Can be more. So light writes is not really right. But what
Yes.
about heavy reads? Where do you think heavy reads will happen?
We read. So no
Heavy reads
idea.
means you're at the time of doing reporting and things like that, you're doing a lot of selects. That's heavy reads.
Okay.
So heavy writes means lot of inserts and moderate reads means medium number of selects. It's not that the selects are low. It's not that they're very high. They're not as high as data warehousing. There are going to be enough selects. They are not low, but they're somewhere in the medium. So A will be right, C will be right. Next, what is normalized data?
Removing redundant data from the table.
One is removing redundant data. And do you remember anything else? Or there is a subtle difference between normalized and denormalized data. Does it remind you of something?
Partitioning a table into two or more.
Good. You're separating the data. Let's say you have an address field. Don't save the complete address into one. So okay, that is one way of thinking. More precisely, think you have persons and cars.
Okay.
Don't save both of them in one table. Save persons separately. Save cars separately. Right, Pravalika?
Okay. Yes, ma'am.
Step 1, you are saving persons separately. Step 2, you are saving cars separately. Then what do you think is step 3 we will do in cars?
Car type for each person.
In other words, we will put person ID in car. But why are we putting that?
To link or to connect both of the tables.
Good. In other words, to know each car belongs to which person. So we are putting person ID in cars table. So what is person ID in cars table called?
Foreign key.
Good. And car ID?
Primary key for that table.
Good. So that is normalized data, separating them. You're partitioning the term. I mean, more precisely, that is separating. Partitioning means again that will different meaning will come. So here we'll not say partitioning, but we are separating persons and cars.
Okay.
Everybody catching the point, guys? Quick yes, please. Now here comes another tough one. What do you think? How do you do? Or what do you think is schema on read, Pravalika?
Creating a schema.
Creating the schema. Okay, good answer. When are we creating the schema?
For writing into the table, like
That is
database.
database. That is schema on write. But here it says schema on read. What do you think that means?
For reading it into the database.
Okay. So in other words, in the world of big data, it is schema on read. In the world of big data or Hadoop, these are some things, and I will ask you to manually by heart. I will force you to keep these things in mind. Schema on read means in the world of Hadoop and big data, you load the data, you first put the data. In the world of database, before putting the data, before loading the data, before writing the data, you're defining the schema. Whereas in the world of Hadoop, you don't define the schema. You just first load up all the structured, unstructured, semi-structured data. Then, based on each requirement, based on each use case, based on each project, we will go to this data and we will read the data based on what we need. So at the time of reading, we are specifying the columns that we need. That is what is called schema on read. This is something you guys need to manually remember. Schema on write is in a database world. Schema on read is in a big data world. Catching it, Pravalika?
Yes, Naveen. But even in schema on write also, we need to load the data, right?
In schema on write, at the time of loading, before even loading the data, you're creating the table, Pravalika.
Okay.
So your schema on write means schema is already there. Whereas when you say Hadoop FS put, nothing is there. You're just putting the loading of the file. You did not say, hey, I want this data type, I want that primary key, or I want this foreign key, because that can be unstructured data. If you take video data binary or audio data, that will be binary data. You just say Hadoop FS put. You don't define the schema for that. Are you catching it?
Yes, Naveen.
That is so schema on read is in big data world. Schema on write is in database world. Now, what is denormalized data?
Combining all the tables into one.
Good one. Combining all of them into one. So what do you think is the right answers here?
ACD.
Very good. See? So that is the right answer. Cool?
Yes, sir.
Good job, Pravalika. So let's see where we are. Gentlemen, ladies, for today, I'll stop it here. Let's continue the journey from here. And if time permits, please try to practice, guys. Review the Azure questions as much as you can. And we'll be evaluating and assessing you again in the next 1 or 2 days and so on, guys. Okay? Everybody okay with that? Please try to spend the time the way I said completely this week and maybe the next week also. Try to focus as much as you can, guys. Okay? You'll be your real evaluation will be coming up when you take the final certification exam. By that time, each question that we'll be giving you, if you can review it a bunch of times, you'll be in good hands and everybody will be happy about that. So that is a little bit of practice. That is going to be your mantra. That is going to be your weapon. Please keep that in mind. Okay, guys, you guys take care, stay safe. Suresh, and how about others? Who else is there? I think you guys were not well yesterday. Are you getting better, buddy? Better? Okay. Good. Keep us posted, Suresh. We'll also keep you in our mind.
Yes, Naveen.
Thank you, buddy.
Thank you, Naveen.
Take care. Thank you. Signing off for today. Stay safe, guys. Thank you and bye for now.